everyone, welcome to the EMEA live stream for Azure Cosmos DB Conf. My name is Iria. I'm here along with my colleague from the Cosmos DB team, Dilip. We'll be hosting the session today.
Hi, everyone.
So Azure Cosmos DB Conf was organized to provide a stage for the whole of global Azure Cosmos DB community to be able to share and discover each other. So over the next 3 hours, you'll be hearing from our customers and community members who have built amazing applications and services. They will show you how they built it and what they learned building on Cosmos DB and for the cloud. You also hear from our partners who have been building applications and just to show you how Cosmos DB is better and easier overall. So when you're sharing your posts about the conf on social media, please use the hashtag Azure Cosmos DB Conf.
Hi, everyone. This is Dilip. This is the last live stream. We are already done with Americas and APAC. So you will hear a lot about our community members across EMEA region. In case if you have missed any of the live sessions from our earlier broadcast, nothing to worry. You can get a hold of all the recordings. So that will be made available on demand very soon. So each of these live sessions over the next 3 hours, we will have a live Q&A with the speakers. So if you would like to ask any questions, which we thoroughly encourage, please make sure you join the stream or the live TV, Learn TV. And our first speaker for today will be Regis Bocaro, who is the CIO from Bad Dog Consulting. He will be talking to us about change feed, Cosmos DB change feed. The topic is Tales from the Trenches. So Regis, over to you. Looking forward to hear about all the wonderful things you have done using change feed.
Thank you. So am I live now? So sharing the screen and all? Yeah, I guess so. So good morning, everyone. Yeah, as you said, my name is Regis Bacaro. I'm a French guy doing Azure architecture and infrastructure consulting. Previously Microsoft employee, also as an architect, and previously data platform MVP. Today I'm going to explain a very shortly a project that we did using Cosmos DB change feed for a financial company, and especially about the challenges we encountered and how we tried to solve those challenges. So briefly, the agenda is what was the problem we tried to solve with the change feed, what were the solutions, because there is more than one, how did we end up scaling up and scaling out on those solutions. Our goal was to deserialize some Cosmos DB documents to put that into a database. So how we manage that, a bit about the governance of this change feed and the whole setup, what we plan on doing on the next steps, and maybe some time for questions. I'm aware that we have 25 minutes, so I will try to do everything quickly and shortly, so there is eventually time for questions. So basically, the problem we try to solve was that we have in this financial company, which is an insurance company, they have bought a third-party financial product, and every time someone makes a payment into their insurance policy, or some money is moving, there is a change into a Cosmos DB document happening, and they wanted to build a enterprise data warehouse on top of these changes, on top of these documents. So it's not just a single collection, it's not just a single database, but the relevance, the relevant collections for this setup was around 80 collections spread over 4 databases, Cosmos DB databases. And the destination is a Azure SQL managed instance. So I'm aware this is a Cosmos DB conference, but managed instance also has proven to have a few irritating limitations where working with deserialization and what was coming from change feed. But anyhow, just very shortly about change feed. Someone has called it the hidden gem of Cosmos DB. It is hidden, but it is composed of 4 parts. The monitored container, so it has the data from which the change feed is generated. Any inserts and updates on the monitored container, they are reflected in the change feed of this container. Then the lease container is like a state storage to coordinate the processing the change feed across multiple workers. So the lease container can be stored in the same account as the monitored container or in separate accounts, doesn't matter. Then there is a compute instance which hosts the change feed processor to listen for changes. Depending on the platform you're using, it can be a VM, it can be a Kubernetes pod, it can be an Azure App Service instance or an actual physical machine, that doesn't matter. It has a unique identifier referenced as the instance name. So, and then you have the delegate. The delegate is the code that defines what you as a developer want to do with each batch of changes that the change feed processor reads. That's very short about the change feed. The life cycle of the change feed is quite simple. You read the change feed. If there are no changes, then you wait a predefined amount of time, and then you read the change feed again. If there are changes, then you send them to the delegate. And when the delegate finishes processing the changes successfully, the list store is updated with the latest point in time, and then you start again reading the change feed. Quite simple. A quick recap of change feed. It's enabled by default in every Cosmos DB collection. You don't need to do anything to enable it. It uses your provision throughput, so it costs RUs. It captures inserts and updates by default, but you will only get the most recent item. It will not keep history. It is sorted within a logical partition, but not across partitions. It has a dedicated collection to keep track of the progress. It can be restarted, although it's a bit clumsy. I will come back to that. The batch size that you want to read, it can be configured in a number of items or size. And it is resilient to errors. So if your delegate fails, the thread of your delegate fails, the processing will start on another thread. Only time where it's not resilient, it's when it's on the first thread when it starts. So for this solution where we need to get Cosmos DB data into, let me find my pointer here. Laser pointer. Yeah, so the first solution that was presented by us, by cloud solution architects at Microsoft, was to, of course, read from the change feed collection, use Azure Function as a trigger, then push the data into Event Hub, and then use Stream Analytics to deserialize the documents, which are quite complex, by the way, and insert them into SQL database tables. With Event Hub, if you're aware, there is a capture functionality, so we could also push a copy of the document into the data lake. So this first solution was not the best one. It showed that not to be the best one. We have quite large collections of documents. I think the largest collection has 26 million documents. And when we started to read from the beginning of all the documents in that collection using the change feed trigger, we had some issues. Also, Event Hub could not follow the amount of documents coming through. You know that also a funny thing, Event Hub can scale up, but automatically, but it does not scale down automatically. But anyhow, we had to drop this solution because it was not performing as we wished. So we thought a bit, and ended with another solution where we removed the event up part. We still have the change feed trigger, but the only output of the change feed trigger was the data lake. And then Stream Analytics was listening to the data lake, so new files in the data lake based on the it's called the last modified timestamp of the files, and then it could deserialize the data and put it into SQL Server. So that should prove to be working. So the Azure function is quite lightweight. We have input binding from change feed. We have output binding to the storage account, and then the Stream Analytics reads from there. It's a bit tedious to work with the 80 plus collection, which means that we have 80 plus Stream Analytics jobs, and when you try to deploy Stream Analytics job using CI/CD, that's quite an adventure. So, but we succeeded, and also one of the purpose of this setup was to move the deserialization away from SQL Server. We could also have used the JSON feature available in SQL Server to perform the work, but SQL Server managed instance was not so performant, so we would have a lot of logs and timeouts. So everything is in Stream Analytics coming from the change feed. Yep. Let's move to the next one. So as I said, we used a very lightweight Azure function. So with an input binding of the change feed and an output binding of the storage account. The configuration is quite simple. If you look at the configuration of the change feed trigger, so it's called Cosmos DB trigger in Azure Function. Then you indicate what is the name of your database. Then you can specify the name of your collection, or you must specify a connection string to your Cosmos DB. You must give a read-write key to your Cosmos DB account, since you need to write back to the Liz collection. Then you can specify what is the name of the list collection, and I will recommend that you prefix your list collection with the name of your collection, so you will be able to retrieve the right collection items based on this prefix if you have many collections. This start from beginning equal true. Means that when you start the first time your change feed function, it will pick all existing documents from your Cosmos DB collection. If you restart your function and the start from beginning is equal true, it will not pick all the documents. What you need to do if you want to reprocess everything is you need to physically delete your Liz documents in the Liz collection and restart your Azure function. And then you will start again picking everything from start. Then here you have the delay in milliseconds for the feed poll. So how long should I wait before asking for changes again? How many items you want to have in every invocation. So here we choose 2,000 items, which was a appropriate size compared to the size of the documents that we have. And then for the output binding, we have the blob output. It goes into the capture. It goes capture the container that we're using, and we have just a connection string with the access key to this container. That's very simple. And you can see from the change feed. Sorry, I have to obfuscate some of the names, but these are all the change feed documents. You can see that for large collection of large Cosmos DB collections with many documents, it will create a lot of change feed analytic leases documents, and for small collection, it will only manage. It will only have a few documents. Sorry, I was reading the comments also. Why it says that live stream is not working on Learn TV. Is there anything I should do, or is out of my hands? So after experimenting with the change feed a bit, we found quite some issues or pain points. One of them is for each collection you want to use with a change feed, you need one function. So here in this setup, we have 80 plus collection. That means that we have an app service with 80 plus function. We could also have spread it around across more than one app service. But yeah, in this case, we have 80 functions in this app service. It's also quite hard to control with the analytics list collection. I mean, when you want to restart from scratch, it's quite a hard reset where you delete Cosmos DB documents and restart your function. And if you have more than one function in your app service, then everything gets restarted. And this is also why you want a prefix to your analytics list collection. Otherwise, you will not be able to control at the collection level if you want to restart from scratch. It requires a read-write key to your Cosmos DB account, and this is also not always welcome by the infrastructure team that you should be able to write in the Cosmos DB collection, although you only want to read documents. Once in a while, we have also seen that documents were delivered twice, but it's hard to reproduce. The way data is loaded in this setup is that they do a lot of batch changes during the night, so from 8 p.m. until 11 p.m., where 98% of the activity is. Then we receive millions of documents through change feed, and during the day there is no much activity. So this not evenly spread during the day load is also an issue sometimes. So far we are still working with change feed, but now we are waiting impatiently on the new solution that is coming, where we have the Azure Synapse link that we will be able to use at one point. So where we can connect directly on the Azure Cosmos DB container on the analytical store and pull data out into Synapse instead of into a SQL managed instance. Here, the idea is that data is pushed in this analytical store, so we don't touch the transactional store. Issue here is that it's not streaming just like a change feed is. So we will need to keep track of where we arrive in the document reading. But once this is solved, we should be able to read data in a nice way using serverless pool, Spark, or SQL as the first stop before we reach the dedicated pools of Synapse. So looking forward to this in the coming months. A few words about scaling up and scaling out. So when you have 90 plus collections or 80 plus collections, we decide to scale up to P2 V2 in the app service. So that's 7 gigs of memory, 420 ACUs. And then we put up a schedule to scale out. So we added up to 8 instances in the Azure function, and this is based on the CPU percentage. So if the first during 10 minutes, the average CPU percentage is over 70%, or the memory percentage also is over 70%, we increase the count by 1 until we reach a maximum of 8. In the same way, we decrease when CPU decreases under 70% for a continuous period of, I don't remember, 3 or 5 minutes. Then we decrease the count by 1 until we reach 1. So we can see that works really, really smoothly. And during evening, where there are peak load, we see that it increases nicely up to 8 and then after that it decreases again to 1. So that's really nice. And this doesn't need to be done for each function. It's at the app service level, so you can have one for the all functions. And here we can see the pattern. You see at during the night, then it goes up to 7 or 8, and the same, it goes down during the day to 1, and then up again every day. It's a really nice pattern. A few words about deserializing, although it's not Cosmos DB or change feed specific. We have to create stream analytics jobs, time 90, and time several environments where we read from the data lake where change feed pushes the change document. From time to time, we see also out of order events. In our use case, it doesn't matter because it's just for being building a data warehouse and BI on top of that. So we don't have an issue with that. SQL Server managed instance also likes to time out once in a while when there is too much load. And we sometimes get warning from Stream Analytics saying that there is a very small difference in timestamps between the events or between the documents that landed on the data lake. So it's just warning us that it could result in out of order processing. A few words about the governance. What we found is that it was hard to govern when you had so many collections. When you look at examples around, then you see that with one collection, it's easy to manage. But in our case, where we had 90 or 80 plus collection, that's a lot of work, and it's also a lot of work to make a CI/CD deployment. I don't know if you have ever tried to deploy Stream Analytics using CI/CD, but that's not funny. That's a lot of work on the DevOps part to make that happen. Also, the process when we try to load from or start from beginning, I find it's always a bit what's called challenging to start deleting documents into a production system, which is managed by a third-party company. So do I dare or do I not dare to delete production documents, even if it's in the analytics list? And worst part is that I have this read-write key. It confers me too much power. I fear that I will do something wrong. So yeah, not a good process. And of course, in large companies, you will have several teams involved in the whole process from end to end. So some infrastructure team making available the different elements that you need and probably giving you the permission on, for example, for the Azure function to write to the data lake, or for the Stream Analytics job to read from the data lake. And when you have many Stream Analytics jobs, then it's also something that needs to be coordinated. Cosmos DB keys also are rotated once in a while, so you need to make sure that you rotate them and you inform the developers or the team that needs to use this change feed that key has been rotated. Otherwise, you will have some surprises. Yeah, so that's about governance. In conclusion, what I found out, what I took out of this project working with ChangeFeed, that ChangeFeed is really good when you work with small bugs, when you don't have data that changes too often, when it's spread out during the day, so you have continuous updates or inserts, so new documents or updates in existing documents. And of course, when you don't need to get the whole history, because you don't get that with ChangeFeed. ChangeFeed is not that good or even bad, I think, when you have many collections, because that's a lot of tedious plumbing that you need to do. And when you have huge bulks not equally distributed, then you get into some of the issues that I mentioned. Yeah, so that was my real life experience of using ChangeFeed in a large setup. I hope it has been some kind of interesting information, and I will be available for any questions throughout the day. And I see that I have less than 1 minute left, so that was perfect timed. Thank you for your time and for listening, and enjoy the rest of the conference.
Hey, Regis, thank you. This was a great session, very educative. And change feed, as you rightly said, is definitely a hidden gem. I had a question on when you mentioned that you were able to handle this with 80 collections, right? So did you have to do something above and beyond what is uh, the regular setup, or did you have to do some extra configurations or some additional plumbing for that?
No, so the tedious part is that you need to have 80 function and 80 stream analytics jobs, and what saved us was that you can specify a prefix to your analytics list collection, so you're always able to see which collection your document in the analytics list belong to, because it will be called the name of your collection and then suffixed with the name of the analytics list document. That was the helping thing. Also, if you want to restart from scratch, you just need to delete those 2 or those 10 documents of these particular collections.
Got it. Yeah, I think it is really awesome to see that you have used it for a fintech solution on the insurance side. You very nicely described the life cycle of a change feed and how it is automatically resilient, right? In case if one thread goes down, except for the first one, automatically it is handled and you get the level that you typically need. I think you are handling the out of order in the application in some way, or it doesn't really matter. So that's a good thing. And it's awesome that you are already using the Synapse integration for analytics, which is very popular these days. And you typically don't touch Cosmos DB. You do all the analytics on a separate destination, right, without affecting the regular reads and writes.
Yeah,
So
exactly. Then it's Cosmos DB's responsibility to push the data to the analytical store,
exactly,
and that I
exactly.
like.
Yeah,
That it's not my problem.
yeah, so it's great that you are already using that. And also, I was really impressed with the way you were able to scale up and scale out depending on the load and the time of the load and all that. So I think it was very educative. Thank you so much for sharing your thoughts on this.
Yeah, thank you,
You're
Regis. Yeah.
welcome. Thank you for your time.
I really like the session. I like the fact that with him talking about how, like with the scaling up and scaling down too, you see how you're able to manage your RUs and all of that. So I think that's an amazing session, Dilip.
Yeah.
I
So what do
think
we have next, area?
our next session will be with Mihail Mativ, and he'll be taking us through, talking us more like presenting to us about the Azure Cosmos DB serverless, and it's titled Azure Cosmos DB Serverless Unleashed. So, hi, Mihail.
Hello,
Hello, welcome.
Hi,
thank you for
Mihail.
the invitation. I'm really very happy that I can join this awesome Cosmos DB conference.
Yeah, we're happy to have you here. Looking forward to the presentation.
This presentation is on one of my favorite areas related to uh, serverless mode. Serverless mode for Cosmos DB is relatively new. It is in general availability from several months. Before it was in preview for a while, and it gives very good opportunity to have different applications in different segments where Cosmos DB in the past was not so popular. I will try to make several interesting points of discussion. First, we will talk about what exactly we consider as serverless, how we will optimize the price, because it is one of the main benefits, of course, for this mod for Cosmos DB. And we will talk about some use cases and several demos. I will start for a few seconds with a few words about Cosmos DB. Cosmos DB, as all of attendees here probably know, is multi-model polyglot database, and till last year, most of workloads were focused on actually solutions with provisioned throughput, where we have guaranteed throughput for our workloads. And when we have usage of Cosmos DB, we needed to reserve this throughput. It was possible to change it depending on what exactly we want. It was possible to make this programmatically or to use autopilot mode, but it was actually quite often my consideration that we need to think about usage of throughput and how long we need to use our Cosmos DB containers. So this is probably the most important, which we will discuss now. Which are use cases, how exactly we can optimize the cost using serverless, and how we can use this in different scenarios. Before to continue, I will just mention two more things, because serverless often is considered in different contexts, and it is sometimes confusing for people. Cosmos DB is serverless in two different aspects. First, Cosmos DB is platform as a service. That means you have no need to think about infrastructure. You use this component without to think exactly how Cosmos DB works behind the stage. From another hand, related to billing perspective, we have two different modes. Serverless, which is the main point of presentation now, and provision throughput mode, which is actually the initial mode supported from Cosmos DB from the beginning, where we allocate certain amount of capacity. So billing of Cosmos DB is related to normalized request units. And Cosmos DB in serverless mode is related to how much request units we will use, and we will pay for used request units. I would like just to remind that for provisioned throughput, we had guarantee throughput with settings which we have for our containers, and we pay hourly for this throughput. And if we have changes of these throughput settings in our containers in specific timeline, which is less than 1 hour, we pay for the highest throughput. That means we need to think always how to optimize this cost regarding to throughput. Now, with Cosmos DB serverless mode, we have no need to think about such kind of additional logic. It is absolutely possible to use serverless mode and to forget for changing of throughput. How it works, we will talk during the next minutes. When we need to use provisioned mode. Provisioned mode is for highly load critical workloads. For such kind of critical workloads, it is important to have guaranteed throughput. When we have provisioned throughput, it is also possible to use free tier, and free tier allows limited resources, which are fine for some small projects, for development, for learning of Cosmos DB. When we have serverless mode, in this case, we have actually throughput which is not specified. We have this serverless mode from the beginning when we create Cosmos DB account. I will show a little bit later this in demos. And in this case, we have some limitations. Yes, it is not possible to have multi-region deployment. It is possible to have only one region for Cosmos DB account. Zone availability is possible. We have a limit of 50 gigabytes storage per container, and our throughput cannot exceed 5,000 request units per second, but it is not something which we can change and specify. For zone availability, it is very good that we can have such kind of availability already for serverless, because high available applications are also important for different scenarios. When we have Azure Cosmos DB serverless, it is not possible to add regions in this mode or to create it. And we will see this, of course, when I go through demos. What is additionally important? It is possible for provision throughput to have most of scenarios which you have for provision throughput to have all scenarios considered in different business use cases. For serverless throughput, we need to think about options where we have not predictable load, and in general, our workloads are not critical, not very high loaded. This is very important for solutions like back office. In our experience, back office applications are one of applications where we can use serverless mode in very successful scenarios, and it is possible to have Cosmos DB competitive to other databases for applications where you have several users, you have not very high load, or this high load is for just small amount of time. Very often in the past, it was really not the best option to manage back office applications using Cosmos DB because of continuous case to optimize the consumption based on changing of throughput. Now we have no need to think about such kind of considerations. When we have in such applications attempts to change the throughput, Cosmos DB returns error, and we will see how it works in different scenarios using demos. It is not possible to try programmatically to change the throughput of containers using Cosmos DB. Um, it is not possible also to create shared throughput databases in a serverless account. It is something which will return error. And as I already mentioned, we have limitation about the size. What is the main specific for serverless, excluding optimization of price when we have unpredictable load for our solutions? We have small specifics in performance, but you difficulty can recognize this difference in performance if you have no very high loaded applications. That means latency in serverless mode, especially when we have writes, can be a little bit higher, but in general, again, I will demonstrate this. We cannot recognize difference in most of popular scenarios. And depends on what load is expected, serverless mode can be uh, cheaper and more efficient, or we can have comparable or even higher than provision throughput when we have critical workloads. Here are examples. In first example, we have workload where is expected to have 20 million request units per month. And we have no very high requirements about throughput. It will be not more than 500 request units. In such kind of comparison, you see that we have nearly 6 times more effective from the cost perspective solution when we have serverless mode. In the second example, we have a workload where expected monthly load is 250 million request units. In this case, already serverless mode stay a little bit more expensive. So we need to have the right estimation regarding to the price. For use cases which we have, I will have a short overview. Serverless mode is very good when we start to work with Cosmos DB, when we learn some specifics of the platform, when we do development, when we have unpredicted workload, and when we have low peaks regarding to the timeline for the overall timeline when we use specific workloads. It is also very efficient for any kind of internal applications, usually in enterprise. We have a lot of applications for internal usage, which are with not very high load, like front office applications for many users workload. Sorry. There is very good integration between different serverless components like Azure Functions and Cosmos DB in serverless mode. Why? Because the concept is pretty similar. We have um, again situation where we have optimization of the resources, and when resources are not used, we have offload of specific resources. What additionally we have for our solutions? When need to create new solutions with serverless mode, we need, after choosing of serverless, to be aware that we have only zone availability and we have limited settings for our containers. Now, I would like to show you several demos. First demo is related to a situation where we have set up with table API. We have table API, which is used with Cosmos DB account, and this Cosmos DB account will be used in two different modes with provisioned throughput, and we will have a second application where we will demonstrate the same with serverless mode. When we run this solution in case when we have provision throughput, we have, in this case, I will change the font, numbers for operations like insert, replace, delete for items in our table, and we will compare the same with options when we will use serverless mode. This is the second application. It is in serverless mode. This is normal setup with average load. We have a scenario where we have 100 rows inserted, replaced, delete, and we can see now numbers. Numbers are pretty similar. Why? Because in non-critical workloads, it is not possible to have a very big difference between latency, which we have for serverless mode, and provision throughput. The next demonstration is related to option when we have solution and we are trying to change the throughput of our collections. You see, in this situation, we have throughput which can be changed in normal provisioned mode. When we start this application and we use provisioned throughput, I will try to run. Give me a second to make it in debug mode. And you will receive error because actually it is not possible to change the throughput using such kind of scenario. So these are specifics which I would like to share regarding to Cosmos DB in serverless mode. You are able to use Cosmos DB in serverless mode using different APIs. It is not only for core SQL API, so you are able to use also table API, you are also able to use Cassandra in this mode, and you are able to optimize your applications when you have unpredicted, not critical workloads, and when you are in situation to use applications for internal use. We have a lot of scenarios for back office, for financial solutions and different kinds of solutions related to enterprise, where now already Cosmos DB is used in serverless mode. We switch the usage of Cosmos DB from provision throughput to serverless mode, and our customers are very happy. This is the most important, which I wanted to share for this presentation. Serverless mode can help you to save money and to think less about how to optimize your solutions. If you have any questions, I will be glad to answer your questions.
Oh, thanks, Mihail. I think it was really thanks a lot for the session presentation. I really loved it. I loved the whole startup of actually introducing everyone to Cosmos DB and having that pause with how it's about Azure Cosmos DB serverless and all of that. And I think it's one thing really is, Dilip, I know you agree with me, is I think it's one thing we see a lot, like, with customers and people that use this, understanding like, throughput, RUs, and when to go serverless and when not to. And with that, I think yeah, explaining that with critical workloads and all of that, and seeing how we kind of like integrate with the different like the different APIs that we use. I'm curious too. You talked about like critical workloads and non-critical workloads, and you talked about like customers that use it using serverless for like banking sectors and all of that. Do you mind going into that a little bit for how they use?
Exactly,
Yeah.
exactly. You know that all enterprise companies have different systems. Systems which are related to a huge amount of data processing for specific timeline usually are considered like critical, and for such kind of workloads is better to have provision throughput, especially regarding to banking solution. Core banking solution is different story. Cosmos DB, in our experience, is mostly related to non-core banking systems. There are a lot of systems around core banking core banking functionalities related to transactions with payments. These solutions are more related to solutions about reporting, about different back office functionalities, because Cosmos DB can be used in many cases comparable to relational databases. We have flexible schema, but we have schema. It is possible to make applications where easy to read and write your data, and you have flexible options to control this data structure. I see here some questions. If we have time, I can answer regarding to education and Cosmos DB, because actually I also do lectures in university, in Sofia University in Bulgaria, and we have two different courses related to big data and business intelligence. And in these courses, Cosmos DB is included like part of core program for education. So we have samples not only with relational databases, but also we demonstrate how multimodal polyglot database like Cosmos DB can be used in such scenarios.
Okay, thank you. I think that's really cool to see how it's how it's been included into like class curriculums for students, and you kind of like get that kind of like experience actually even before you go out of school. Thanks a lot, Dilip. What? Yeah.
Yeah, I think, Mihail, you hit the nail on the head. When the traffic is unpredictable or it is intermittent or the systems are not used continuously, it is idle for a long time. I think the way you put it out is actually a perfect fit for serverless. And also for when you're introducing this to college students and people who are trying it out new, it is very difficult for them to come up with what will be their load in the future. So they can start with serverless, get an idea, get a look and feel of what their to be load is going to be, and then they can plan for whatever works for them from a cost perspective, how the application is used, and whatever is the ways and means how things work, right? So I think excellent session, and I really enjoyed all the tips and the information that you provided. Thanks a lot.
Thank you.
Thank you very much for the invitation. It was an honor for me to join this conference.
Thank you.
Thank you.
Same here. Thanks a lot.
So, Dilip, that was amazing. Who do we have next?
Yeah, that was a great session. Our next speaker for today will be Mark Duiker, who is a senior developer advocate. He's going to talk to us about something very interesting, right? It is about building a fully featured scalable chat app. So we have lots of chat apps, lot of people who are onboarding to seeing how they can sort of collaborate and socialize with each and everyone. So Mark, looking forward for your session on this.
Hi, Mark. Welcome.
Thanks both. Thanks for having me. Yeah, I'm looking forward to talking about how to build a fully featured and scalable chat application with all of you. So my name is Mark Duiker, and as already mentioned, I'm a senior developer advocate at Ably, where we enable developers to build real-time experiences. I'm also a Microsoft MVP for the last couple of years, especially focused on the serverless area. You might have heard about Azure Functions University. I'm also a big fan of pixel art. So I've also made this drawing that you see here, which is our Ably DevRel team. So what am I talking about today? First, a bit of high level about real-time in general. Then I'm going to talk about the chat application, what it is, why the DevRel team is building it, how are we building it. I'll be highlighting some advanced features that we're going to build. I'll definitely talk about the local development experience. And finally, I will show you how you can contribute to this project. Oh yes, there will definitely be a demo right after I will explain some of the real-time communication aspects. So first we're going to talk about some real-time communication in general. So we see more and more organizations doing stuff on a data-driven way. So what does that mean? Well, they actually use data that they collect and base decisions on them, right? So they collect data and using that data for their decision-making. And I think it's great, right? It's always better to use real data than just use estimates or guesstimates and make important decisions on those. So a lot of these organizations are gathering loads and loads of data, and that's something that we call big data. So they usually have a data lake. That's one of the other speakers also mentioned this morning. You have a data lake, and we store all kinds of data there. And usually we do some analysis and reporting on top of that. Also, again, to support decision making. So that's already a great step that's being made by a lot of organizations. So the next step on top of that is we're actually going to use real-time data for decision making. So, and especially at a very large scale, that can be quite a challenging thing to do. If you have lots of data coming in and using that data in real time to make business decisions. So that's quite a nice challenge, and it's a very nice problem space to work in. So talking about real-time data, well, it's really everywhere where we look. So if you are doing some online course, you can probably chat with your teacher there or work together on your homework assignment. Well, we've all been doing quite a lot of video conferencing last couple of years, so I think we're all pros in that now. When you order something online and you get a notification that your delivery is on its way, you can track your package. Social networking is also a big player where you can take an image and post it online. People can respond to it or like it. That's also done in real time or near real time. Collaboration tools, for instance, Office 365, where you can collaboratively make a spreadsheet and do some calculations together. And gaming is a big one, especially MMOs, where you have big multiplayer games where you need to exchange a lot of information online. So it's really everywhere. A lot of these use cases I've mentioned involve some kind of a chat component, right? So in online education, but also in video conferencing, you can usually chat, and in these collaboration tools, you can usually chat as well. So a lot of our customers are building something with chat functionality. So and that's what I'm going to focus in this session. So FFS chat, it's a bit of a cheeky name, but in this case, it stands for Fully Featured Scalable Chat. So what is it? Well, in just a couple of words, it's a production-ready example or demo of a chat application. So let's first go to our demo. If you want, you can scan this QR code, and it is safe, I promise, or type in this link to go to the application. So this is it. It's running live. So here you can see what we've built so far. We can see the history of the chat. Some of my colleagues were so kind to send some chat messages yesterday. So you can click on a profile to see a bit more information. Soon we'll be implementing direct messaging. So this doesn't work yet. So the work is still in progress. Of course, we can type something. And we have multiple channels where we can communicate in, and I didn't show you yet, but you're actually required to create an account and to log in into this application. So that's also taken care of already. So this is what we're currently building. Okay, so why are we actually building this? And with we, I mean the DevRel team at Avely. Well, over the years, we have collected quite some documentation and code samples and GitHub repos that cover all kinds of aspects in the real-time space. And so we have written and demoed about connections and WebSockets and small chat applications and dealing with user presence and pops-up patterns and all that kind of things. But the information was mostly geared towards beginners. So we have a lot of beginner content, but almost nothing for really advanced users. So we got a lot of requests from either customers or people from the community that they would like to see some bit more advanced level information that they could actually refer to as kind of reference architecture or a demo that they could use. So they wanted something advanced level, as real life as possible, that showed integrations with the cloud, that highlights multiple features of our APIs, and that's actually also scalable because a lot of our customers really demand a really high scale. They send millions of messages to many thousands of users. So also the scalability aspect was very important. So then our team decided to create a new demo, which is much more than just an Hello World sample, but really quite a big involved demo that to cover all of these aspects. So let's briefly touch on the domain objects and some of the features that will be implemented. So whenever you're dealing with chat, you always have these domain objects. So you can communicate in channels, you have the chat messages themselves, you have users and user profiles, and there are roles or groups. So all of these have some CRUD functionality. So you can create them, read them, update them, and delete them. And for the channels, users, and roles, we actually persist them in Cosmos DB. The messages themselves, they are sent via our platform, Avely, and for historical messages, we currently store them in blob storage. So this is, let's say, the basic functionality that whenever you build a chat application, you have this probably covered. But let's look at some of the more advanced features. So one of them is user presence. So there are quite some communication tools that shows you either a green circle when a user is online, or a red circle when they're offline, or when they're away, for instance. So that's also something that we're working on, and we want to have available in the chat application. Search is also something that we can work on. So we want to search in all channels, to search and message content, also to search for users. We want to handle mentions and notifications. So when someone types @markduiker, then I will receive a notification in my application. Authentication and authorization, that's already implemented. So we have a, let's say, a native login for FFS but we also have implemented Auth0. So we support 2 ways of signing. And we're also going to work on chat moderation. So we can add some words to a deny list. So people, so either messages are blocked immediately or they're first need to be reviewed before they are then publicly available to the rest of the channel. So yeah, let's hope it's clear that we're not talking about a basic hello world chat application now. So how are we building this? Well, this is one of the first diagrams that were drawn, and this is our to-be architecture. So it's not where we are at the moment, but we're getting there. So you'll see some familiar icons. We see a lot of Cosmos DB. We see a lot of Azure Functions. We also see Azure Static Web Apps. We see some Azure Search and API management. So a lot of it is in place, but not everything yet. So I'll actually guide you through a simplified version of it. So our application is hosted in Azure Static Web Apps, a relatively new service in Azure, which I'm really enjoying a lot. You can use it for hosting all kinds of front ends, but also have some backend functionality in the form of Azure Functions, which is super useful. And I'm a big fan of Azure Functions. So in our case, we have a React front end. And the React front end is mostly communicating with the authentication part. And for real-time messaging, it's communicating with Ably. The backend is Azure Functions, so we are writing them in TypeScript. And that's mostly communicating with Cosmos DB and also a bit of blob storage. And that's used for profile images and a bit of historical messages. So this is the high-level overview of our application. These are the 4 most used components that we touch on, let's say, on a daily basis. So anything that deals in the real-time space. And so we have communication between a React component and that then sends messages to Ably. And Ably is then responsible for delivering these messages to all of the other connected clients. So anything real-time, that's taken care of there. Anything that deals with management of channels or users or roles, that's handled then by Azure Functions, which are triggered from the React components. And that then calls to Cosmos DB. There are some instances where we actually trigger Azure Functions from Ably, and I will come back to that a bit soon. So let's briefly talk about real-time versus near real-time. So I'm going to talk about distributing your application state, right? So as you're typing a chat message, you have that state on your local chat client, but that chat message is not yet delivered at all of the other people who are in the chat application. So as soon as you hit the enter button, that message will be sent and should arrive at the other connected clients. So that can be done in a couple of different ways. One way, and that's using Ably, it's using a publish subscribe pattern. So user 1 that types a message, it publishes a message, and other users are subscribed to the same channel. And Ably is then responsible for delivering that message to everyone who is subscribed to the channel. So that's a very common pattern. Lots of providers do this, and it's very useful if you're doing real-time communication. Another pattern, which is more near real-time, is I am posting some information, but I'm posting it to a central server, for instance, a central database, for instance, Cosmos DB. And instead of that central entity distributing the content, all of the other clients, all the users, need to go fetch that content. So that's quite a different way of distributing your application state. So now my clients are responsible for actually being up to date. And usually this is a bit slower because we don't exactly know when some content is delivered in Cosmos DB. I'm not talking about the changes. So if you're using the Cosmos DB change feed, of course, then you can still trigger something else, for instance, an Azure function, and that function can probably use signal R or something like Ably again to also trigger the client update. But I'm not talking about that yet, so that's not how we use it at the moment. So let's make this example a bit more specific, and let's say we have a channel that has 1,000 users in it. So if one user publishes a message that needs to be distributed to the other users, the 999 other users. So in total, 1,000 messages will be sent, right? So we're sending one, and that needs, and 999 one will be sent. But what if everyone in the channel will be sending a message at the same time? So then we have 1,000 publishers, and each of them need to receive the message from the other users. So in that case, it already results in 1 million messages. So by changing the scale a bit, that can result in quite an impact in the number of messages that are sent. So, and of course, when you're dealing with chat messages, you want it to be real time, right? You don't want to wait a couple of seconds before a message arrives. You want to receive a message as soon as possible. So PubSub is still a good idea. But what about a status change, perhaps? So maybe you go offline or online, or you change your status and saying, okay, I'm off to lunch for an hour. Is it then still useful to broadcast that in real time, or is a near real-time solution then maybe good enough? So let's have a look at an alternative way to do this. So in this case, it's near real-time. So we still have 1,000 users that send, let's say, a status update. They still push it to Ably, but on the Ably side, we can configure a webhook that triggers an Azure function. And that Azure function then posts the state information to Cosmos DB. So now Cosmos DB has that new updated state, but the other clients do not know about it yet. So they need to actually get that information. But instead of now needing a million of messages, we now only have a couple of thousand operations or messages to get to that distributed state. So yeah, those two solutions are completely different. They're not really comparable, but it's important to realize that you can solve the same problem in different ways, and some might have some benefits, and some consequences. So it's important to know about these differences. So I think what I'm trying to say here is that always look at your application architecture under different perspectives. And so there are some well-known perspectives, such as look at it with the security, and look at it via scalability and performance. Look at it using availability and resilience. Look at it from an evolution standpoint, and so how well easily can your application undergo any change, so it doesn't fall down easily. And all of these perspectives have an impact on cost as well. So the same is true for using PubSub for everything, for a real-time solution, or using a near real-time solution. So sometimes it's a bit of a trade-off between functionality, real-time versus near real-time, which definitely is an impact on cost. One of the very nice things is you can definitely do quite a decent estimation of your costs, especially when it comes to Cosmos DB. So Cosmos DB has an online capacity calculator, and that allows you to make some pretty good estimations on how much you'll spend every month regarding your Cosmos DB storage. So you can specify which API you're using, the number of regions, and what is very nice, you can actually specify the workload that you're expecting. So you can specify how much storage you'll be using, and then even how much CRUD operations you're doing. So it really takes some time to analyze this, what your expected workload is, and then to translate that into numbers you can use in the system. But I really recommend everyone to do this, because you don't want to be surprised after a couple of months and see that you have a very high bill because your application is maybe very successful. A few words about local development. So I think having a good local development and a very quick inner development loop is very important when you're either using some open source project, or you're just onboarding on a new team, because you don't want to spend days and days setting up your local environment. So since we are using Azure Static Web Apps, there's this very, very nice CLI tool, Azure Static Web Apps CLI, that you can use to emulate your whole Azure Static Web Apps environment. So you can run it completely locally on one endpoint. So you have this one endpoint available, and behind that single endpoint, you can have your static content being served. You have your Azure Functions local runtime running. And you can even emulate your authentication and authorization. So this is really ideal for debugging either your front end or your Azure Functions backend. So the CLI tool is, I love it. It's really a time saver. If you want to read more about it, I definitely recommend this blog post from Anthony Chu introducing the Azure Static Web Apps CLI. Another tool which I think is great is another emulator. It's the Azure Cosmos DB emulator. Maybe you've seen Sean Wildermuth's session in yesterday's Americas track, because he had a session dedicated to the Cosmos DB emulator. So if you haven't seen that, then definitely watch that back. Again, it's a tool you install locally, and when you run it, it opens up a browser where you see this. And all this is very similar to what you see in a portal, because in this slide, this is what is actually there in the portal. So this is the real Cosmos DB, but this is the Emulator View, which is very much the same. So you can see which database you have. You can create and manage your database and collections here. You can create new items. You can read items. And of course, you can. This also allows you to connect your local application to this emulator. So again, this is really nice for a very nicely focused inner developer loop. The final thing I want to say about local development is code spaces. So that's another thing which is relatively new. So code spaces are developer virtual machines hosted in the cloud, and this one are hosted by GitHub. But they're really ideal if you want to get up and running quickly with a new GitHub repo, for instance, especially if your own machine maybe is not really powerful, or maybe you're not allowed to install any tooling, for instance, on it. Then this is really ideal. So there are two ways how you can use it. You can either use it completely from the browser, so you can even just run it just from a tablet. So it starts up a new VM, and it loads your GitHub repo there. You can even specify some commands that you want to initialize in case you want to install some additional tooling. So this again is very nice for you if you want to get up and running quickly with a GitHub repo. The other way how you can run this is actually you can still use your local machine and open up Visual Studio Code, but then you can connect to to one of these remote VMs. So then it's a bit of the best of both worlds. So you can still use your local VS Code, but you're connecting to a remote VM that holds your code, and you can do development and build environments there. So if you want, this is our GitHub repo, fully featured scalable chat app in ABD Labs. So if you hit the code button and you see local first, you can clone it. But there's also a code space tab, so you can create a code space, and then you have the entire GitHub repo running in a VM. Final point, how you can contribute. So I already shown you this page. So this is our GitHub repo. We are developing this completely out in the open, licensed under a Apache license. So you're completely free to take this and run with it, make it your own. That's totally fine. The README is quite extensive. So if you don't have code spaces or don't want to use it, we have a very extensive README that will describe in detail what are the prerequisites, how should you install everything, how to get everything running. It describes all of the components that we've built so far. So I think this will definitely help you if you want to have a look and either just test it yourself or help us contribute. So this is the QR code for the GitHub repo. You also see the full URL there. I'm very curious about your opinion, so definitely let us know. And feel free to help us out. So we'll soon start working on the chat moderation tool. We'll be working on private messaging. We'll be implementing search, media previews in messages. So if that sparks your interest, please do let me know. And if you have new ideas of other features we could implement, please contact us or create a GitHub issue in the repo. If there's any questions, I'll be hanging around here in the chat. You can also approach me on Twitter @MarkDuiker. And if you want to talk more about the real-time space, feel free to join the Discord if you want. And thanks, everyone.
Hey, Mark.
Yeah.
This was a very interesting session. I think everybody is familiar in some way or the other because we use a lot of chat applications.
Yes.
I had one question. So if there is a website developer who is starting new and he wants to provide some type of customer service or whatever, right? Enable some type of chat with the user, either for recommendations or to answer the questions what the user may have before he buys a product. Can they just integrate your module, the FFS chat module, directly into their application? Is it something that is easy?
Well, this is definitely, let's say, you can definitely take this and integrate it in something else, but this is it's more designed like a standalone chat application. So it's more intended like a fully full chat
peer-to-peer.
So it's not a small chat component that you implement in an existing website to quickly talk with customer support, for instance. Because those usually don't need chat history or presence information or things like that. So yeah, what you heard from our customers is really that they want some next level example of a chat application. And for most of the, let's say, quick questions and answers or customer support chats, there are quite some existing components already out there, which you can easily drop into your website and straight go up and use it. So this is more like a bigger standalone web application for it.
Right. I also had another question on the security aspects, right? So you mentioned you are talking about roles, creating the roles, assigning certain permissions, and then doing authentication and authorization, right?
Yeah.
So are you using any of the Cosmos DB components that is natively available, or are you planning to handle this from in an external source or through the application itself?
Most of it, the authentication is either done internally where we create our own users, which are then also coupled to API keys on the AB side, or we do it via Auth0, so you can bring your own provider there. To a certain extent, it integrates, of course, also with the capabilities you have in Cosmos DB. But we're not using all of the native Cosmos DB capabilities regarding to roles there. No. That's definitely a good point we can look into more as well.
Sure.
Yeah.
No, I think this was amazing. You touched upon the concept of real time and near real time. And you also explained it very lucidly, right? Like how a message needs to be real time, whereas a status update can be near real time, and how how you are storing the different types of data in different systems, right? Like the chat history and maybe the profile picture and all that, you are keeping it in blob storage because it can take some time and also occupies more space. There is not real like immediate need for something like that. You can always fetch it later. But at the same time, you explained very nicely on what is real time and what type of data can reside in real time. So I think this was exciting, and hopefully more people can join the bandwagon and contribute towards this. Looking forward for a more fully featured app in the near future.
Yeah, that would be great.
Yeah, I really loved it. I think I learned to just like describing like the whole architecture of, the whole objects and everything. I never put so much thought into like when you're designing a chat app. So with all that, sequence of how it goes, I was like, oh, wow, okay, it's a lot.
Exactly. Yeah. Usually when you see chat app, it's just like any other chat app. But there's a lot of stuff going on in the background you might not see directly. So
nice. Thanks a lot. Thank you.
Cool. Thank you.
So we have another great session coming up, and we have our next speaker for today, Dilip, is Jean, and he's a co-founder from Linkros. Hi, welcome.
Hello, my name is Jean, and I'm super excited to be there.
Thank you. Thank you. He's going to be talking to us about how we investigate fraud using Azure Cosmos DB. So I know this is going to be exciting. So I have my whole, investigative cap on to listen.
Awesome. So let's kick things off. I'm going to be talking about investigating fraud with Azure Cosmos DB today. My name is Jean, and I'm one of the co-founders of Linkurious, a startup that specializes in helping folks bust fraud and money laundering networks. So first, a bit of an agenda. I will explain briefly why graph analytics and anti-fraud are really a match made in heaven. Then I will be doing a bit of an introduction to our Linkurious Enterprise product. After that, I will do a demo to showcase in practice to combine Linkurious Enterprise and Azure Cosmos DB in an anti-fraud scenario. So let's kick things off. First, today's criminals are smart and getting smarter, and they know how to bypass existing fraud and compliance processes, at least the smart ones. And they have really a bunch of tactics for that. Sometimes they work as a group to exploit a scheme that works. Sometimes they break down suspicious transactions in small chunks to fly under the radar. They also use opaque corporate structures with lots of companies, some of them headquartered in offshore banking centers, to obfuscate who the true owners of a given entity are. And finally, they also use synthetic identities by mixing together pieces of personal information to create fake identities. So they really have a bunch of tactics that they can use to bypass the existing controls. The common thread across all of these tactics is that if you don't have a full understanding of the context surrounding a client or surrounding a transactions, it's really hard to uncover what's going on. And here in this slide, you have a bit of an example of that. You can see a seemingly normal client. And maybe if I look at that seemingly normal client in isolation, maybe just that person, his date of birth, his latest transactions, things of that nature, it's going to appear like a good normal client. But if I'm interested in the connections, in the context around that person, I see that it's that this person is connected to an order, to a transactions, and ultimately to a fraudster. And this insight, the fact that this seemingly normal client is actually connected to a potential criminal, that should help me reassess how I'm perceiving the risk of the client and potentially upgrade that risk level. So once again, it's really imperative to have an understanding of the context surrounding clients and transactions to uncover the schemes used by smart criminals to defraud bank and financial institutions. The thing is, it's changing. It's changing for a number of reasons. First, traditionally, in a lot of institutions, there's simply too much focus on simple thresholds and anomalies. Things such as how many transactions have happened in the last N days, or is this in line with the client's past behaviors? That type of analytics really do not take advantage of the context that we just mentioned. Another big pain point is that the suspicious connections that are so important are rarely uncovered. Both the analytics and the tools that are made available to the end users to visualize the data are typically focused on narrow aspects of the available data. Maybe they're looking at just the transactions or just the personal information, and it's really siloed in terms of an approach. And then that means that it's really up to the investigators to explore the various ways clients can be connected to one another and to other entities in order to make decisions about whether a particular behavior on alert is suspicious or not, and also to spot anomalies. And finally, there's just too much false positives. A lot of anti-financial crime teams are spending too much time and too much of their thin resources chasing false positives instead of adapting to new threats. So really, there are a number of challenges that are getting in the way of organizations that want to put context at the center of their anti-fraud approach. The good news is that Azure Cosmos DB and Graph Analytics can help connect the dots and help anti-financial crime teams understand the connections across the various data silos to understand the context around any client, any transaction, and with this information, spot suspicious relationships and potential fraud or money launderers. So that's why we, at Linkers, we are so excited by Azure Cosmos DB and its graph capabilities. And we have built a product called Linkers Enterprise. So this is an investigation platform. It can be connected to Azure Cosmos DB in minutes. And with this tool, anti-financial crime teams can very easily search their data, explore it dynamically, and ultimately unmask fraud and money laundering networks. All of that in a collaborative and secure environment, which is very important for effective teamwork. Here you can see a bit of a screenshot of the Linkers Enterprise UI, and we can see, particular client, Gardenia Red, and what it is connected to, plus some information about that client that we are currently looking at. So that's really what the Linkers Enterprise UI looks like. And with this software, all clients are able to accelerate their investigations and uncover fraud and money laundering rings that would otherwise go unnoticed. So here are some of the key capabilities of Linkers Enterprise. First, there's Graph UI, which is powered by Ogma or JavaScript graph visualization library. It leverages WebGL to make it possible to display and interact with thousands of nodes on the screen at the same time. We also provide a search engine backed by Azure Search, with which you can easily search for nodes and edges in a very intuitive way. You can also filter the data, slice and dice it based on time, space, quantitative properties, and more. You can also collaborate and save and share visualizations across users. We also provide the ability to turn repetitive or recurring investigation workflows into buttons and forms via what we call query templates. And finally, all of that is secure with the ability to define fine-grained access rights and support for Active Directory, Azure ID, and a single sign-on, and of course, SSL. So that's it in terms of a quick introduction to Linkers Enterprise. And now I'm going to talk a little bit about how to combine Azure Cosmos DB and Linkers Enterprise. So here is a bit of a schema where it all starts with legacy systems, with internal data, external data. This data needs to be prepared and moved to Azure Cosmos DB. So you can use something like Azure Data Fabric to handle that type of workload. So that's one possibility. We also have clients that are using tools such as Azure Databricks to also leverage machine learning capabilities and enrich the data with properties representing the riskiness of a client or transactions. At the end of the day, all of this information it needs to be put into Azure Cosmos DB, and then that can be. Then you can plug Linkers Enterprise to Azure Cosmos DB. And it's a very simple process. It can take a few minutes. Then you need to configure the access rights to make sure that the right persons have access to the right information. You can also set up some alerts, some query templates based on your requirements. And once it's done, your end users can very easily leverage the data and start uncovering new insights. So Linkers Enterprise is really an accelerator. It can help turn the data that you have in Azure Cosmos DB into something that can be used on a day-to-day basis by any members of your investigation team. So that's it for a quick overview of how to leverage Azure Cosmos DB and Linkers Enterprise. Now I'm going to go through a bit of a demo of using Linkers Enterprise to uncover fraud and money laundering networks. In this demo, we are going to use a dummy data set representing what a bank can have about its clients. So in this dummy data set, we will have clients. We will have some personal information related to those clients, such as emails, IP addresses, phone numbers, and addresses. We will also be looking at financial transactions. Folks moving money around. For the purpose of this demo, we are going to play the role of a fraud analyst. We've been notified that a particular client called River Wisdom is acting suspicious and hasn't been paying back a loan that she has, and we want to investigate her to understand whether something fishy is going on, or if we are just facing a small payment delay issue. So we are going to be using Linkers Enterprise to do that, and we will see how it makes it possible to really dive into the Azure Cosmos DB data to uncover insights, all of that with very limited coding knowledge. So let's get started. I'm going to switch to another screen. So this is the Linkers Enterprise UI. Right now I'm connected to Cosmos DB instance. I'm just going to show you how it works. So this is the interface that is used to configure Cosmos DB. It's fairly simple. You provide an endpoint and your credentials plus some extra information, and you can get started. So it's very easy to set up Linkers Enterprise and to connect it to an Azure Cosmos DB instance. Going back to the visualization now. I mentioned that we are going to investigate a client called River Wisdom. So let's type some text. There's fuzzy matching. So it means that as we type, we see new results pop up. So this is the result that I'm interested in. River Wisdom. I can see where the match happened. So we have a full match on the full name, for example, partial match on the last name and on the first name. I can click. I can see the results. I can see on the left a bunch of information related to River Wisdom, such as a country. So River Wisdom as United States as a country. Full name is River Wisdom, and so on and so forth. Of course, all of this information is entirely customizable, and it depends on the data that you have. What is interesting right now for me is that little 5 next to River Wisdom. So it represents the number of undisclosed relationships that River has with other entities. I can double click and retrieve all of these connections at once. If I want to, I can also be more fine-grained about my exploration. Maybe instead of retrieving everything, I just want to retrieve the bank account or the IP address. So it's fairly easy for me to be strategic about how I want to explore the graph, which is super important when dealing with a large complex graph. Okay, going back now. I'm doing what I just did. We also provide within the interface the ability to automate workflows via Gremlin and what we call create templates. And I'm going to show you an example of that just now. So we are looking at River Wisdom, and I'm going to click here on an inquiry, and I'm going to type to click on N level of contacts, and I'm going to look at a form with a number of ops that's already suggested. I can switch it, but the freeze is fine. And that create template is going to give me the 3 level contacts of River Wisdom. I'm going to click on Run. And there it is. I can see that River Wisdom is connected to a Gardenia ret by via this address and indirectly via these two bank accounts. So it's really a way. To automate this type of query. And now I'm going to show you what it looks like in the background. So this is the query that we called. I'm going to click on View Details, and we can see what it looks like. This query. So this is some gremlin code, and we can see that there are some parameters that are left to the end user to specify. So, for example, the end user is providing a starting point, which is a node. Then the end user is also providing a number, which is the number of ops. And then you can see the actual query that works with these parameters. So the query templates are really a way for developers and data scientists to turn, to leverage Gremlin to automate some of the investigation workflows and make that really seamless for the end users. We can call these advanced functionalities with the click of a button. I'm going to pull some more data into the equation. So I'm selecting everything, expanding. This time I'm doing that manually, I guess. And now we have some more data on the screen. I can zoom in on a part of the network, for example. I can see that one client or this server one. What is interesting to me right now is really the fact that we started off with just one person, River Wisdom, and we can see that this client is actually connected to multiple other persons. So we have Gardenia Ret, Aline Royal, Philippa Life, and Mark Jordana. And these persons are connected across transactions, which is fine, but also across personal information, such as a shared address here, a shared IP address there, another address here, and a phone number there. And this is more suspicious and potentially indicative of a network of fraudsters. We are recycling pieces of information to create multiple profiles, multiple client profiles, in order to ask for loans with the intention of not paying them back. So that's an interesting insight that I'm getting out of my exploration of the graph. If I want to, since there's a bunch of data on the screen, I can use different ways of representing it to see if there are some interesting things that come up. So I can plot the data on a map. So I can see that we have two addresses located somewhere in the Chicago region. Okay. I can also use the filter interface within Enterprise to remove some of the non-relevant nodes or relationships. So maybe I'm not interested in the non-financial part of the network. So I'm removing the IP addresses, maybe the loans, let's say, the phone numbers, just to focus on people and bank accounts. I can be more fine-grained about that. Maybe out of all of these bank accounts, I want to locate the ones with the most transactions, or the biggest total amount. I can make this sort of choices. Here, for example, I'm going to filter the bank accounts with the lowest total transactions to locate the one with the most transactions. So this one and this one have free transactions. So it's really a way to focus on the important part of the graph, and you can do that as an analyst without having any knowledge of graph theory or graph analytics. Closing the panel now. You can also group relationships. If you have multiple relationships between any two nodes, you can group them to make it easier to read the graph. you have access to a design panel where you can customize the look of the visualization, add some details such as icons, colors to convey as much information as possible via the visualization UI. And if you have uncovered something of interest, like we have right now, we can save the result. Let's go with a suspicious case title, I guess, saving the visualization now. That visualization that we have created, we can export it to a number of formats such as Excel, PNG, SVG, so that it can be reused elsewhere. Typically, in a report or PowerPoint presentation about what we have uncovered. It's also possible to actually share the visualization with another person. Let's say I'm working with Wong for my team. I can, give her access to what we have created with the ability to modify or even modify and share. I can do all of that really via a simple UI. Going back to the dashboard now. So I hope that I've been able to explain and showcase very concretely how Linkers Enterprise can be used to dive into your data and quickly uncover fraud and money laundering networks. Going back to my presentation. Okay, so there are really three reasons why all clients are choosing to combine Azure Cosmos DB and Linkers Enterprise. The first one is just the fact that we deliver faster investigations, 10x faster investigations with graph visualization. It's possible to understand the context around any situation, no matter how complex the underlying data really is. And the difference that it makes is that it becomes possible to act quickly and with confidence instead of wasting time choosing information scattered across different tabs and across lists, bar charts, and so on. So that's one big advantage. Another advantage is that it becomes possible with Linkers Enterprise to leverage graph analytics to catch and to go beyond simple rules to catch professional fraudsters. The traditional anti-financial crime rules can be bypassed by sophisticated criminals, and with graph analytics, you can uncover complex fraud and money laundering schemes that would otherwise go unnoticed. And finally, it's super easy to get started. So there's a built-in compatibility with Azure Cosmos DB, and right now we are rolling out in the Azure Cosmos in the Azure Marketplace the ability to deploy Linkers Enterprise. This is right now in beta, and you can contact us if you want to get access to this new offering. Our software is trusted daily by thousands of investigators worldwide. We are working, for example, with Wells Fargo, with the Empire Street, and with the Attorney General Office of New York, among others. Thank you very much. If you want to learn more about Linkerius, or if you want to try Linkers Enterprise, you can reach out to contact@linkerius.com. Thanks.
Yeah, thanks a lot, Jean. I mean, that was really amazing session. I really love the, how you talked about Azure Cosmos DB and, graph analytics, helping, unmask fraud with, laundry rings. I guess I understand the challenges too, sometimes with, we're talking about false positives and like suspicious anomalies. If we're not able to catch that, it kind of like leads up to, having those false positives. So I guess one question I have before going forward, I did see something which had like, where you mentioned like the number of hops. You mind explaining what that means?
Yeah, sure. So when you're in a graph, you can go from one node to another one by via relationship, and that's that's called making a up. So when you are looking at nodes that are 2 ups away from your starting point, you are really looking at nodes that have a couple of intermediary steps, I guess, in the graph.
Okay, thanks. Yeah, I like that too, because one question I had before, and then you kind of like explained it, was I was curious about if 2 people were from the same IP connections, how you're able to handle that. And I see having that workflow where you can see people from the same IPs and having all of those connections, seeing if they're connected. And then just like the map view too, like the visualization is awesome. Having that map view where you can narrow down on the streets or be able to filter based on the person or the accounts, and just seeing how all of this is, made possible with, having an easy compatibility with, Cosmos DB, I think was awesome. And thanks a lot. Dilip?
Yeah.
Thank you so much.
Gene, I think this was very intense, very critical for financial organizations. One question I had, or more of a curiosity, is how do you get the data? What is the source for all this data? Do you generate data on your own, which the banks will, when they sign up for your enterprise or whatever, right? Do they get access to all that data, or how do you actually make sure that this meaningful data is available with you to do the analysis?
Sure, great question. So with clients, I mean, we don't have any proprietary data at Linkers. And really our clients are mostly focusing on leveraging the data that they already have, think personal information about clients, such as, address, email, phone numbers, that type of things, or transactions. And I would say that's where there's the most value, and that's the best place to start, because there are really some low-hanging fruits in this data. And then the more advanced organizations are really looking into adding to that external data. So there are a bunch of data providers out there that can give you access to information about company ownership. Think this company has this and this person as owners, that type of things. Just like in cybersecurity, you can get access to information about various threats. So it's more complex to get this external data and mixing that with your internal data. Typically, there are some entity resolution changes there, but it can create a lot of value.
Sure. I think that's a big thing. Owning the data and sharing it in a way which is going to help financial institutions prevent fraud. I think that is also a bigger challenge, and I'm sure that there are a lot of people thinking about how to do that more effectively.
Yeah. Thank you. Thanks a lot, John. Thank you, John.
Thank you so much.
Thank you. That was great. And Dilip, what's next?
Yeah, I think the sessions are very exciting, and we are sort of deep diving into a lot of aspects. Our next speaker for today will be Jake Hattis, who is the CIO from Longview. He's also going to talk to us something around Graph in some way.
Nice.
He's going to talk to us about how to use Gremlin API and Apache Airflow to facilitate complex system integrations.
Wow.
So,
yeah, I feel
Jake,
like
over to you.
we're a bit. Gene did a little bit of work for us in showing us what the eventual application of Graph can do for us, especially with financial institutions and fraud. What I'm going to be talking about is how you can actually. You asked that question just now. How you get that data into the Graph in the first place, and so my session here will be talking about sort of our journey and how we went through, and then I'll sort of share with you how you can not only model your data for Graph, but then also implement that with continuous delivery. We've done that through a number of different systems, including Apache Airflow, but I'll go in a little bit more detail around what what sort of graph is, what Gremlin is, which is the language. So a little bit in the last session, the language to traverse a graph or to speak to a graph. We'll go all into it. But a little bit about myself, just as you spoke. My name is Jake Hattis. I'm the CIO of Longview. And a little bit of plug about Longview. Longview is a property service firm based out of Melbourne. We're here down in Australia, if anyone is listening from the Southern Hemisphere. We're a little bit of a different company in the sense, if you work in property down in Australia or you've heard of it, it's often very operational based. The data and analytics is often separate. It's by different providers, different companies, and what makes us a little bit different is that we try to combine those two. We have field expertise, and we need analytics, and that requires a little bit of a different approach in terms of technology. And about a year and a half ago, we realized that across our business we had 7 or 8 different business units, all using their own individual work management systems. And one of the business units would enter data that would be applicable to one of the business units over here. And so we needed to get data from there over to there, but we didn't necessarily want the business unit A over here to have to use the system for business unit, the business unit over here. And so we needed to implement an integration layer, and a kind of database layer that sits across our ecosystem, across the different work management systems, and connect them. And so when we started to look into that and what the possibilities are, we came upon Graph and Cosmos DB, and we ended up using and building our database layer using the Gremlin API in Cosmos DB. And so I want to share with you sort of why we did that, how that came to be, and how you might potentially be able to do that yourself in your business. Because as you'll see, and as we go along, Graph and Gremlin allows you to essentially scale complexity. And you'll notice if you have any number of different systems in your business, it becomes very, very complex very, very quickly. So just a little bit of agenda of what we'll be going through. First bit will be just around sort of modeling your business data using Graph. Talk about what is Graph, what is Gremlin. We'll talk about and then so how you can use a structure to then model that data in a graph structure. And then we'll talk about the actual infrastructure behind it and how you can get the data from any of your work management systems or any systems that you use into the graph continuously. So we'll talk about the systems involved there, the architecture, and sort of what is happening from a continuous development perspective using the architecture that we've worked on. And not to say that that's the end all be all, it's just some of the insights that we've gleaned as we've worked on them ourselves. So let's kind of talk about, graph and modeling. And the first thing is, for those of you who don't know what graph is, it's a database. And I like to think of it as really firmly a perfect meshing of a NoSQL database and an SQL database. The benefits of an SQL database is that you have that relational tabular data that allows you to sort of connect various different tables and various different items all together, and you're able to sort of connect all of those into various views and access that. But it's not very flexible, right? Not like SQL, NoSQL, which gives you that sort of JSON document structure that allows you to change structure and schema depending on the document itself. But the problem with NoSQL is that you don't necessarily have that relational aspect, that relationship. And so what Graph does is it takes that flexibility of the SQL, of the NoSQL document, but then gives it a relationship. And so if we look at this sort of structure here, in Graph, they're defined as sort of nodes and relationships. And you sort of saw that in the last session where, we see sort of IP addresses, and we have houses, those are different nodes and they're connected by a relationship, right? But that sort of defines the graph structure, and at its base, you sort of build from that sort of simple idea. And Gremlin, which is just one of the various languages and APIs that are available in Cosmos DB for you to interact with. I think Cassandra is another one that you can use, but Gremlin is just the language that we use to traverse the graph. And when we say traverse, it truly is traverse because you are hopping from one node to the next. And you'll see as I have a few examples here that show you sort of how Gremlin interacts or sort of how to think about the graph and how you write those queries to interact with it. To do that, I've sort of given you a bit of a model. And at the top of here, you can sort of see what it looks like in the graph, right? So we have nodes. We have 3 nodes here that are all sort of the same label or collection. They're all people, all with different names. So they're individual items. We have Frank, we have Jake, and we have Bruce. And then we have the relationships between them. But one thing that you'll notice is that there's a directionality to the relationship. So one node needs to be connected to another, but there needs to be some kind of indication of a direction between sort of where we're going there. You know, if you think of a tree, it has to branch out from somewhere. And the same is true in terms of a graph. And that's why you see when you look at the various sort of models out there, graph looks like this huge web. It's beautiful, but that is what lies in its power, because you can traverse it and you can aggregate and the various relationships that are coming out of it that you're creating inadvertently or consciously or unconsciously. So when we think about Gremlin and how that works, it all sort of stems from that idea of directionality between the different nodes. So if we look at this query here, we are essentially asking the question, who are Frank's friends, right? And so we have Frank and we have Jake and Bruce. We're hoping to figure out who Jake and Bruce are. But how does that represent itself in Gremlin? Well, every Gremlin query starts with a g.v, and if you were to just plug in g.v into your terminal, you return every node in the entire graph. So if you have 100 million nodes in there, all of them would come back. So we can now sort of, this next section here, which is just to filter it and center ourselves on the point in the graph that we want to start with. And then we're going to move out from there. And that's sort of what literally the keywords are out and in, right? So in this query, we're centering ourselves on Frank, and we're asking who is friends with Frank with a direction out. So it's this relationship between Jake and Bruce. When we run that into our terminal, we're going to get a list of nodes or objects that correspond to that relationship from the corresponding node. And so that's a little bit of Gremlin. What I wanted to sort of show you is and especially in our business, because we were connecting various different business units in the work management systems, we needed to bring them together in a way and build out the relationships between the existing systems. And so data that was coming from one system and we needed to define the context of that data in terms of the other systems. And so what I've tried to do here is I've modeled it out what you would see using SQL. So we have 2 different systems here. We have a work management system that manages, because we're in property, we do inspections, we manage applications and tenancies corresponding to properties. But in our ecosystem, we have a system that manages the inspections and applications, and then a separate system that manages the ongoing tenancies in the properties that we manage. And then, of course, so I delineated between those 2 systems between the colors. Of course, contacts are going to be coming from both. So, when we're pulling data out of one system, it could be via API or another database, backend access. We're pulling that out, and we have applications inspections. We have contacts from one system. We have contacts, tenants, and properties in the other, and they're all many-to-many relationships. So in SQL, how we would represent that is we'd have our sort of core tables corresponding to the sort of key entities, and then we would connect them using these joining tables. If we were going to look at that as it represents in graph, it becomes drastically simpler, because we don't have to worry about extra sets of of tables to join the various tables together, because it's inherent in the relationship. And that's another sort of core aspect of graph, is that it is on a one-to-one basis. So, a record, if you think in terms of SQL, if you were to connect one record to another record, you could do that, and it would represent itself in the graph. And so, for us, we can remove these joining tables and represent them through relationships. Let me pose a question. According to this sort of structure, right? When did the current tenants of a property, say prop 1, with an ID of prop 1, when did they inspect the property? Usually what we see in terms of property is someone inspects the property, they apply for the property, and then they become a tenant, and once they're accepted. So, if there was a business question of, when did this tenant, the current tenant, inspect the property, how would we necessarily pull that out of the database? If we had structured that integration, that database layer, using SQL, we would need to write this really nasty long query, lots of subqueries, joining tables, just to pull out a single piece of data. If we look at that corresponding query from Gremlin using Graph, it suddenly becomes just a single sentence. And you can kind of see what we mean in terms of traversing the graph, because it reads like a sentence, right? So, we're centering ourselves on prop 1. That's the node that we're starting with. We want the tenants that are renting the property currently. We want then going to move to the contacts that are renting, that are tenants that are renting the property. We're going to go from that contact node out that are connected to inspection. They attended an inspection, and that inspection was for this property 1. And then we can just pull out the values, the date. So it becomes very simple to manage those complex relationships using Graph. And I often like to talk about it, but when we started modeling out the data in our business for across, I think it was 2 systems in particular, just the beginning sort of cornerstones of these systems, and I just found myself, I had 15, 20 different tables that I was working with. I wasn't sure how I was going to be connecting, contacts over here to contacts over there, and what if that inspection connected to this application. How would all of that work, and how would I maintain that? Because that's highly complex, and that's just 2, and we have another 5 that we need to build in there. And my chief data scientist, reached out and was like, "Oh, have you ever heard of Graph?" And I think it was within 2 or 3 weeks I was able to essentially simplify that entire process, the entire complexity, into a working model. And it was the right call. We were able to essentially map out data and relationships between that data effectively in a scalable manner across the entire business. And so, when we're talking about how to model your data, because it does take a little bit of a different frame of mind to when you're sort of looking at that data that you need to connect. I always find it to be helpful to sort of look at the structure in terms of a table, and sort of if we're sort of reading this, we have only 3 columns. We have the node, we have the relationship, and then we have the node. If you think about it that way, I always found it very helpful, because you start with the entity itself, and then you can expand on what those relationships are to other nodes. It could be the same node, right? But it all starts with just identifying what it is are those, those tables, what are those entities that you need to label and collect, and that will scale, or you need to identify as a group. So, in this example, which we're just continuing on from before, we only have a few nodes. We have contacts, inspections, applications, tenants, property, pretty easy. And then you build out those relationships, or you start to flesh those out, or what possible relationships could there possibly be there. So, and this is just a very simplified version of this, but you can see where you can continue to expand it out. So a contact, here we have a contact that attended an inspection, and that relationship is key. But a contact could be, say, a brother of another contact. A contact could be an aunt, it could be a referrer for another contact. You can just start to see where this simple table becomes very complex and very long, because there are so many different relationships that you can define. But once you have an idea of not only what those relationships are and the directionality, so if we're reading sort of left from right, we know that we're defining a relationship from a contact to an inspection. And so if we were going to look at that and think of that in terms of Gremlin, we would think, a contact out, attendant in, and we would receive an inspection, because we've predefined that relationship and the directionality there, left to right. We can then expand, because we have our relationships. You can kind of see here in this map here, we've taken the relationships from before and we've just mapped them. But for each of those nodes, each of those sort of labels that we have, there are properties or there are pieces of data that we can use to fill out that information. And so, and that is accessible to us when we're looking to expand in that kind of those queries and different pieces of analytics or pieces of information that we need to pull when accessing different pieces of information. And so, for an application, we might have the date submitted, the application status, any comments that we have, for a property, you have your address fields, your status, your latitudes, your longitudes. You can start to fill that. And if I haven't sort of scared you already with how much data you can, pack into this simple structure, the relationships themselves can have properties as well. So, we could have a date field for this registered for relationship. So we know it might be inherent inside the inspection, so we may not need it. But you can start to see where you have relationships in the node, you have properties in the nodes, and then your properties in the relationships. And so it becomes a very meaningful way to represent reality that you previously couldn't do without bringing in and having to manage that scaled complexity. So now that you have that sort of, that model, you've modeled it out, you need a way to actually implement it. And you need a way not only to, maybe you've established a graph, but you need to get that data out of the systems. You need it to go into the graph, and you need to keep it updated, and you need it to be robust and available, and you need it to be independent. And so what does that necessarily look like? What is that architecture? In our experience, we used we found the best system that worked for us was a system called Apache Airflow. And if you don't know what Apache Airflow is, it's an open source data orchestration tool. You install it on a server. We have ours on an Azure VM. And essentially what it does for you is it consolidates your pieces of data orchestration or your data processing to what they call DAGs. And the DAG is very specific. If to simplify it just greatly, if you have system A and you have system B, and you need to get data out of system A and you need to do some stuff to it and push it into system B, all that stuff that happens in the middle is a DAG, a DAG. And so in Apache, in Airflow, what you can do is you can define specific DAGs, and within a DAG, you have tasks. So a great example of this is, we are, at least along we've defined some standard tasks that we have for each DAG. We have a pull, we have a process, and we have a push, and you can expand from there. There may be some DAGs where we have multiple pushes because maybe that DAG needs to push into multiple data sources. Maybe it's going into the graph. Maybe it's also going into an OLTP database, or maybe it's going into an blob storage for backup. You can define all of that through Airflow. It handles all of the it handles the logging for you. It structures it for you. It executes it on a trigger. Airflow is a really amazing way for you to expand that especially as you grow larger and as you need more complex data orchestration tasks, it's a way for you to manage that in a scalable manner, in a more robust and available manner as well. So we used we implemented Apache Airflow, and of course we use GitHub for our sort of our versioning and our code development, and then we used the Azure Container Registry to then deliver the actual code that's being conducted inside of Airflow. So inside of Airflow, when we're talking about DAGs, you have a number of different options for you when you're executing sort of this data processing. You can operate sort of within Airflow itself and use some of the native APIs. You will have the option to use a Docker container and containerize that solution, and then use the entry. The DAG essentially uses the entry point of that Docker image to then execute the code. And so we've chosen to use that because we can deploy the latest solutions, the latest DAG, and the latest container or code that needs to be executed in a continuous development through an architecture that looks like this. So let me walk you through sort of what that looks like. So we have we have our Airflow server. We have a container registry which holds all of our Docker images that we use to deploy to that we use to run our DAGs. And then we have two specific repositories in GitHub. We have one that is the actual DAG itself. So within that repository, there is the code that runs the DAG. There's also the Docker file. That is synced as a submodule to this, the company-wide DAGs repository that holds all of the DAGs that the company is executing and running at the same time. We've initialized that as a remote repository on the DAGs folder in Airflow. And we then use the container registries to push our latest image. So what that means is when we're developing, we can commit a change or an update to the DAG file, whatever it is, whatever that data processing file that we need to do. We commit it to GitHub. That updates the repository in GitHub. We then use a GitHub action to connect via SSH to the Airflow server to update the local repository of the Airflow DAGs repo, which then updates its submodule. So that change that comes through, that we just pushed through, is then immediately available on the Airflow server. So we don't have to worry about a CP or any sort of file transfers to get that in there and active. It's ready to go almost the moment that we commit it. And then we have a separate file that we use to then deploy our Docker image, the latest build of that Docker image to the container registry. So what that looks like when a DAG executes is in a DAG you sort of schedule what that is to execute and when it's supposed to run. When it does that, it pulls the latest image from the container registry and executes the DAG, but the DAGs that are defined are from our company-wide Airflow repository. And so in a single, we can very easily and agilely update a DAG or data processing, and we can deploy it, and we don't necessarily have to worry about it being present in the right places, or that the DAG that's running on Airflow is using the latest image in Docker. It's all seamless, and so we can focus more as a team on the data itself and how it's being processed in the code and making sure that it's bug free and able to actually run. And so when you sort of combine all of this together, we can essentially update we have DAGs that we have 20, 30 different DAGs that are running at the same time, all pushing data from our various systems into our graph that we can then use to either facilitate data from one end of the business to the other, or we can do analytics on the relationships that are being generated from the data that we pull. Or in other cases, we've actually built integrations between ourselves and other companies using our graph database for people to access it. It has truly sort of revolutionized the way that we have integrated data and thought about how the relationships between the different elements of our data itself. So that's everything that I have on my plate. Thank you for listening to us, and I'll be in the chat if you have any questions.
Thank you.
Hey, yeah, Jake, I think this was a good 101 on graph and how to approach data modeling for graph databases. So I had a couple of questions on this Apache Airflow, right? So
Yep.
how different is this when compared to a ETL tool? Because you're talking about DAG and you're talking about pushing the data to multiple destination systems.
Yep.
How different is it from ETL, and can you configure something which is specific to every destination, like send some level of data to system A and don't send something to system B? Can we do all those things in
Absolutely, and yeah. So Airflow, I think, is just another ETL tool. There are so many out there, but it's
Okay.
just another one. The reason we really liked it and we engaged with it is that it did give us that amount of control. If we needed to push, if we did need to push one form of data A into system A and another form into system B, we have that potential. We actually were just writing a DAG the other day where we were taking a dump of a Parquet file, pushing it into blob storage, taking that same data, manipulating it, and then pushing it into an OLTP SQL database. So it's all it gives you that control, which is exactly what you want, because that data needs to be in the right format to go where it needs to go, right?
Sure. And this consolidation of multiple business teams that you were talking about, right, for which you implemented the project. So was the destination database, in this case, Cosmos DB and Gremlin, which was later used for further analysis and deep diving into the data in some way, or this was just one of the databases which was a destination in this case?
No, so we built a comprehensive database layer in Cosmos DB with the Gremlin API, and that had all of the data that across our business within that graph. Okay. It isn't completely done yet. It still continues to grow, but we have found that in addition to that graph, we use it to then influence other databases that we're continuing to build OLTP or OLAP solutions.
Makes sense. No, I think this was a really good lesson for somebody like me who is not like deep diving into graph right now, but I was able to correlate a lot of aspects of how to visualize things, and it was it was good. Thanks a lot. Arya, any thoughts on this?
Yeah, I thought it was really cool because I really know about, like, we're using Airflow most times and moving the data. Most times I've noticed like a lot of systems like copy the data over the raw data and then try to read that back so you can do some of the cleaning instead of doing it on fly in case the DAG breaks. So yeah, I think with this session and the previous ones, having this whole intro to graph and everything, I think was really cool. So I'm like, okay, yeah, it's nice. Thanks a lot, Jake.
Thank you for having us.
Awesome.
Thank you.
Yeah, I think we are having great sessions back to back.
Yeah.
So what do we have next, Arya?
So next we have our next speaker is Thomas from Albuquerque. Forgive my way of pronouncing. He's going to be talking to us about how to get work done faster with Apache Studio and Azure Cosmos DB. Welcome, Thomas. I got hooked there for a minute.
Hi, Area. Hi.
Hi.
Hello, everyone. Yes, thank you for the introduction. Yes, my name is Tomasz Daumut from Alpaca Studio. I'm really happy to be here. I'll be talking about our tool. It's a professional data studio for Azure Cosmos DB. Just as a quick note, please excuse my voice. I got a little cold today in the morning, so I'm trying to manage that. So Alpaca Studio is a professional data studio for Azure Cosmos DB. It comes as a managed application. You can run it self-hosted if you need that extra layer of control, and a desktop edition is coming as well. Today's session is going to be a demo, actually. So I'll be showing to you Alpaca Studio in action, and I really want to focus on the aspects how we help software developers in getting more work done faster when interacting with Azure Cosmos DB. So I want to make sure that they aren't put in the position that they have to write extra code just to do some basic management tasks. So this is where Alpaca Studio comes in and tries to help in different stages of software development when using Azure Cosmos DB. And we'll be looking at 3 areas. So how do we interact with Azure Cosmos DB using our data studio? How we can look after after the data health, and how we can do some performance tuning. And afterwards, we'll be looking at the roadmap for Alpaca Studio. But let me switch to screen sharing. Just exit the demo. There we go. So Alpaca Studio, as you can see on my screen share, is a data studio that is able to connect to Cosmos DB. What we see on the screen is on the left-hand side, we see what Cosmos DB accounts I have connected. We see my accounts, databases, some containers, and on the right-hand side, we show you the data. So the challenges that our customers were facing all the time, they tell us that whenever they were building an application, they felt a kind of difficulty of verifying, is the data in the shape I expect? When I'm writing the data, what is actually landing in the database? So the portal from within Azure gives you some opportunities of verifying the content of the document, looking at individual documents at the JSON format, but it's very difficult to get the bigger picture, and this is where Alpaca Studio comes in. So what we did here is we show you the contents of a container. Let me just zoom in a bit. And what we did is we actually look at every single individual document, and we try to discover what fields you have in there, what properties you have in there, and we group them in a basic, simple, and something that's easy to understand in a table view. What a lot of users expect from a data studio. So we see that we have the field that's called ID, a mandatory field in Cosmos DB. It's grouped together. Then we see the field state. It's always a string. We see it's a partition key, and it's grouped together. So it's really great when you come into a project that's already in development to see what type of data I'm dealing with. Or when you're building data, you're building a product and you have potential bugs in the software that happens initially and later in phases of the project as well, that sometimes maybe data is missing. We have the address field. We see an entry here. We see an entry that's missing. Maybe that's expected, maybe not. It's a NoSQL database, so some fields can be there, some fields could be missing, but still, it's very difficult to discover those potential anomalies when you just look at the JSON view in the portal, and it's extremely easy and comfortable to discover when you use a table view like ours. So we see that we have some data in here. We see the addresses. Let's go further. We see another example here. We see a field that's called is open. So we have some data in here, whether the business is open or not. And we can spot that something might be off. We see that there's a value true, a Boolean. Sometimes there's a 0. Maybe it's an indication of the value false. We don't know. So we'll be looking at it in a second when we look after the data health. But already that basic view gives you great power because you really see what's happening. Another one, when we go even further, we see some potential typos. So we see a field that's called postal code, postal underscore code, postal code. So again, a scenario when you have a lot of developers working on a project, there could be a typo somewhere in the code base. And it's really difficult to spot that when you look at basic JSON view. So I'll be zooming in and out in the screen, but I hope that's easy to follow. So with Alpaca Studio, in the basic, simple table view, you can really spot anomalies, discover what type of data you're dealing with. And it's really great when you want to get an overview of what's happening. Another time saver here is that you have the ability to actually edit data. So think of a scenario when you're building an application, you see a small mistake in the database. You could either change your code base, add a special case for repairing that data on the fly as it's being discovered, or you could maybe do those edits and fixes on the fly while looking at the data. So one example is editing individual documents. So scenario of building an application, testing how would the application behave if the data changes, or maybe there's something different and missing. So what I can do, I can just click here and I can just, correct a mistake. And I can just do it. The update has been performed on the fly behind the scenes, and I didn't have to fiddle with JSON. I didn't have to be too careful with editing and being worried that I'll destroy my JSON format. I just corrected that one field. So it's really great for those individual surgical operations. And returning to our example that we had here, we see postal code, POD code, and so on. Those are some potential mistakes that could be fixed in code, but you can just fix them quickly using Alpaca Studio. So what I want to do here is I would just to make sure that postal POD is renamed to postal code, and the same with the camel case. So what I can do, I can just right click on a field like that. I can go to our bulk operations mode. I can say I'd like to rename a field. And now I have the ability to say, well, let's just fix the field name. And I don't want to do that edit for the current document. I actually want to do this for all documents in the container. So it's really dangerous and powerful, but it truly is a lifesaver and time saver. And it's one of the most common, most popular features in Alpaca Studio, actually. And we get a lot of positive feedback because of that. So I will just do this now. Off we go. The operation started. And what happens now is we load document in batches. We edit them, we fix them. We did all tests. We did all safety controls here. So you can be reassured that that operation would just happen behind the scenes easily. And you don't need to write that code for that. So it's done. It's a smaller container. Let's just refresh the view. And when we go there, we see that one of those incorrect field names has disappeared. So we managed to clean up the data. And that's really, really, really helpful. In that scenario, we were really editing live data. And we gave you the opportunity to correct some mistakes. So you get an overview, you see what data you have, you can do individual edits, you can do bulk edits, and there's more to come when you discover the tool on your own. A quick note, in the table view, you have the opportunity to change to other views as well. So if you really want to use the basic JSON view, it's available in here. So you can look at individual documents, maybe in group, maybe you discover something. And you also have the tree view here, and that's great. As the name suggests, it's a tree format, but it's really amazing when you're coming new to a project and you want to look at the structure of the document. So instead of trying to decipher JSON, you just look, you can collapse and expand, and it really helps to get the gist of, what do I have in the data? How does it look like? What do I have in here? And that's another feature that really gets a lot of positive feedback from our customer base. And with that section, I will stop in that interactive section of looking at the data. So I showed you how you can look at it, how you can explore a little bit, and now we'll be looking after the data health. So let's switch to the table view again. And I mentioned that we have a potential anomaly in the data. So we see a field that's called is open. Sometimes it's a true, a Boolean value. Sometimes a zero, a number. So there's some indication when we just look at what is it, 20 documents, we can increase the page size to maybe 100. So you have a potential indication there could be an error in the source code. Yes, somebody who's writing the data is making a potential mistake. And again, it's something you can fix on the fly when you work with the data. In your code, you could just correct those small mistakes while reading and writing documents. But it's another effort and another potential risk. So that's something that you would like to avoid. And with Alpaca Studio, we can look at this in more detail. So 100 documents, it's not enough. It's just a sample. So what we built here in the tool, we have the so-called schema analyzer. So before we go in, let's just take a look at one of those individual documents one more time. So you see this is how the documents look like. You know the JSON view inside out. So we have some fields here. We have the field is open. It's a true in that document. Another one we open here. We see there's a 0. So this is what we are after. We want to discover if it's a mistake across the entire database, entire container, or maybe it's something that's just local to that 100 document page. So what we do, we'll go to the schema analyzer here. And I already rerun the scan before our presentation. So what we do here is we show you all the properties, all the fields that we've discovered, pardon, that we discovered in the container. We show you the name that we've seen. We show you the probability. How often have we seen a document, a field like that? So let's go to the field is open. You see that we've seen it 100% of times. So it exists in every single document in that container. And we see that the data type, something is consistent. Sometimes it's a Boolean, sometimes it's a number. We know that sometimes it's expected, sometimes it's something that you want to have in your data, but it's not always the case. So let's look at this. So we can expand that name here to get more information. And now we see that actually the Boolean in here, the data type, has been seen 80% of times, and the number has been seen 20% of times. So what does it mean? I can hover over those fields. Unfortunately, the tooltip doesn't scale here, but what I see here, the Boolean, it tells me that the false value has been seen 0 times, the true value has been seen 900 times, and for the number, I see that the min and max is 0. So it's a strong indication that actually we had a small bug in the application, that instead of writing a false value, we've been writing a 0. So now we have two paths. We can correct it in the application, or we can just make the small bug, kill the small bug in the application and just clean up the data easily. So let me show you how we can do that. From that schema explorer and schema analyzer, whenever you see something, you can just right click on that field or on the value or the data type, and you can ask Alpaca Studio to show you all matching documents. What happens behind the scenes, we write the small query. Afterwards, you can look at this here in the expert mode, but we did a query for you and we selected all the documents that have that special property. And we know it has the value 0. We know it's always a number, so we just want to fix it. So I can right click on it. I can say, hey, fields, edit the field here. I would like to change the data type to a Boolean, and it should be a false. And we want to do the change to all documents matching current query. Let's do it. Again, what happens behind the scenes, we read all the documents, we do those changes for you. And once the operation is finished, we'll be able to refresh the field, the view, and we'll discover that the data has been fixed. So what Alpaca Studio gives you, it's really the ability to really interact with the data. Our customers were telling us that they had the feeling of having a barrier between them and the data. So they can interact using the driver, they can interact using the custom code that they write, but very often they really want to look behind the scenes in those interactive scenarios and see, is what I'm writing in the data actually landing in the database? How does the data look like? Can I really extract something? Can I write a simple query using the tool? And this is what we gave here. So it's really the ability of looking after, exploring, discovering some data health issues and fixing them. Okay, I think the operation is finished. Yes, it's a completed task. So let's go to the schema analyzer and rescan it quickly. And we should be able to discover once it's done that the small mistake here has been fixed. Well, we'll return to that in a second. And that we don't have that data anomaly in our database. Okay, let me just zoom out a little bit. All right, it has been loaded. We see it's open, beautiful, 100% of times, always a Boolean. And when I look at this, I see some false and truths in the data. So we've been able to recover from a potential problematic mistake easily. The same, we see that we still have some typos in the postal code field name here. So again, that's something that we could fix from here and have it done. And I have to tell you, in the past, I've seen a lot of ways of writing the field name email with dash, with camel case, with everything. So we've been doing that quite often in the past. So that's why we really wanted to see the future. And again, that's something that's heavily used with Alpaca Studio today when we ask our customers. So please feel free to give it a go after the presentation. Now, we've been looking at, because of the time constraints, of course, I was just limiting myself to a couple of areas, but there's really a lot more features to discover in Alpaca Studio. But we looked already at that interaction with the data. We looked up some data health, and in just a minute, we'll be looking at what you can do about performance tuning with Alpaca Studio. But before we jump in, I wanted to show you something else as well. So when we interact with the data, we often do some edits, we often do some changes, as I did now. And that's something that happens very often in dev. So you're building an application, you're testing something, you want to get your test data back in and see how your application behaves. And that asks for some easy way of moving data around within Cosmos DB. And we started doing that. We have the first iteration ready for you. So what you can do with Alpaca Studio is you can really easily copy and paste containers. So it's really a small Azure data factory built in Alpaca Studio for those small operations, like moving data from A to B. So what I will do now, let me just close that for a second. I will take my small container that's called Yelp Business as seed that I typically use to restore my demo data. And what I can do, I can just say I'd like to copy the container. And now I'd like to paste it to our container that I used for the demo. So I can just say, well, paste the container here. And what happens, we tell you, okay, you'll be copying data from A to B. You'll be asked what you want to do when when we have a conflict. So maybe I'd like to overwrite the document because I really want to restore the demo that I had. And if I run it, I'd be able just to get my data back. So it's really great for developers when you start building applications, when you want to see what happens, when you want to do some changes. You can have a lot of experimental data and just move it back and forth, or just pull a quick copy of your data. And that's really, really powerful and heavily used as well. What we added, because it's so popular, we added request unit limiting or throttling. So that's something that helps you to avoid potential side effects when you move a lot of data potentially from or I see a question. I'll just answer in a second. So what we do here is we can really put some limits. So we can ask Alpaca Studio to slow down and not exceed the limit that has been defined. So what it gives you the opportunity to avoid side effects in production if you maybe pull data off production or write it to production or do an edit. So I see a question come in from the audience. Interfere with that in large database requirement. So the question is, how do request unit limits interfere with that? In large databases, a query might not run because it exceeds the limits. Yes, so we have no ability to avoid that. So if there is a huge load on the database, we'll be struggling at the tool, but we'll be trying to reconnect to rerun the query. For queries in the data view that we showed you before, we'll be timing out after, I think, 30 seconds, and we'll tell you there was a problem, and we'll give you exact details, whether that was D429 or another error. When we move data around, we try to get to the request unit level that you have defined. So for example, on the target, I could say, I don't want to use more than 700 request units, and that's what we'll do. But in case of those 700 request units not being available, we'll just struggle and slow down. With Alpaca Studio and operations in progress, you can reconfigure. So when we run it, you can go to the task and you can change it to speed up, slow down, or you can pause the task, or you could also abort. So you have that control. One remark, that 5,000 here is not hard-coded. We discover from Cosmos DB what is the amount of request units provisioned for the database. So in my case, for the demo, we have a serverless database here. So that's why it's 5,000. If you have more, that slider will let you do more. I hope that answered the question, but if not, please just follow up here. Okay, but let's just, start the copy of the container. What will happen now? We start reading and writing. We show you how those request units behave. And again, you can go here, as I mentioned, reconfigure the task, and you could say, well, let's just limit it heavily on writing, and it should start slowing down. And now the data is being, so it starts to slow down slowly and adapt to the new threshold that has been defined. So that's the operation here. Okay, I think we have 15 minutes. Perfect. So, but the takeaway here is that we have the support built in for those easy operations with moving data around. We have that ability of editing data in bulk. When you edit data in bulk, again, you can provide those request unit thresholds. So inside out through the application, whenever there's operation that runs over a longer period of time or touches more than a couple of documents, you have the ability to control how many request units you want to provision for that operation. So it's operation based, it's not per connection. Based on user feedback, we could potentially add that, but today it's really per operation. So you really need to look after that when you run those operations. But the safety net here is the ability to reconfigure. So when you notice something's happening, you can quickly pause, reassess, change the limit, run again. Excellent. So we looked at two areas. We looked at interacting with the data. We looked at some different views. I showed you how you can copy data between containers. You can copy data to new containers. You could repartition your container, because once a new container is created, you can provide a new partition key and so on. So you have all those features built in already. So it's truly a lifesaver, time saver, sorry, when working with that. You looked at editing documents individually, and you looked at editing documents in bulk. And there's, of course, more of those features hidden. So when you log into Alpaca Studio, look at the small buttons, use right click, see what's available, and you can always just contact us, and we'll be more than happy to jump on a brief call to show you the tool in action to address your specific use case. For interaction with the database, you have a lot of ways of writing a query. So you can either use the basic form in here. That's great for simple, quick operations. You can use a visual query builder if you just want to click around and explore a bit. So that's available under the button Query Builder. And if you really want to go wild and write a big query, you can switch over here to the expert mode, and you get a lot of real estate to write the query. And you actually also get an auto-completion here. So it's not just, syntax, but you get auto-completion for, field names, because we scan these containers, we see the schema, and we give you some advice. We help you writing those queries faster. All right. So data health, that was another topic that we covered. We looked at how you can use the schema analyzer. Oops, I closed it by accident. How you can look at the schema analyzer, how it can help you to see what types of data do I have, how you can find matching documents, and how you can use bulk edit to fix potential anomalies. And now the third section will be a little bit of performance tuning. Some of those features are already available. Some of the features are in dev. So we'll be switching to my dev environment in a second, and we'll be releasing them in the next week or so. But I really wanted to show it to you today during the conference. So performance tuning for Alpaca Studio and Cosmos DB, it's an important topic. So we know request units, there are some limits. You can over provision, under provision. And Alpaca Studio starts to help in those areas. So the first thing that we did is we gave you the opportunity to actually see what's happening. So let me run a simple query. So let's do a basic filter here. Let's do some sorting around the query. So I'm just filtering on the state, Arizona, and I'm sorting by timestamp to get the newest documents here. So we get the result. It's quick because it's an interactive tool. But what happens if we do a lot of those operations? That could be very expensive. So let's switch to the performance tab. And we show you more data, more information about the query that we just ran. And we see that the request charge was quite high here. It was 10 request units for that simple basic operation. And that container has whatever, we were running some scans 1,000 or 2,000 documents. So it's a small container and a quite expensive query. So, the question is why? Of course, if we run a lot of those queries, it could make sense to optimize here. So it's always a trade-off. If you don't run that query that often, it doesn't make sense. Sometimes it does. But let's imagine we do a lot of queries like that. And what we get, the Cosmos DB team, they provided great index advisory features in the driver, so they exposed and we are able to use them. So actually the query engine tells us, what indexes have been used and what are potential indexes that could help you with running the query faster. So we see basic query, we see 10 request units, but on that performance tab, you see an index summary, and we show you what indexes have been used, potentially, utilize index, state, timestamp, and the Cosmos DB team provides us with some suggestions, what type of indexes you could potentially add. So you see that there's a suggestion to add the index on the state and on timestamp. So well, let's just do it. So Alpaca Studio has a built-in index editor. So I just click here. We open it on the side. We see the definition of the indexing policy. We see that the current indexing policy says, well, we just index everything. E tag is excluded. And there's a new index that was suggested by the performance advisor, ascending on state and ascending on timestamp. So, well, let's just do it. So let's just click save. What happens? We submit the query. It's a small container, so we see that the reindexing has been done. So let's just close it. Let's rerun the query, and let's hope. Yes, let's see. So we are down from 10 request units down to 3, and we see that the index here has been used. So it's really something that is actionable. You can try out your query here in Alpaca Studio. You can see what are the costs. We provide you with more details that there will be more explanation on that later, but not during the session. But we really give you all the actionable information here and the ability to quickly add an index and see what's the outcome. So you can use Alpaca Studio to copy a subset of the data, see what happens, do some experiments, and then apply it to production. So the index editor is available always on every container. Right-click, edit indexing policy. You see a visual representation of the index. If you need to go more and do something more advanced that you think it's not covered here, you can switch to JSON, or maybe there's a new feature that will be added by Cosmos DB team. You can just edit JSON here or use the visual representation for quick edits and just do those changes. All right, so this is something that is already available. So when you log into Alpaca Studio, you'll be able to see what index do you have, what are the suggestions, what are the proposed indexes here, and you can just use them. So it's really, really helping and really easy to use, and we'd like to encourage you to try it out. Now I'll switch to something that's coming. So it's a little teaser. We just have some finishing touches on that. Oops, I'm sorry, it's timeout. So I just quickly log in the meantime. What we have here is the index advisor that looks at your documents in your container. So we're looking at, let me just zoom in a little bit. So it's the same container, you know it already. But what we added here is the ability to discover, what is actually the impact of my index on my write performance, because that's something that's very easy to be overlooked. So we look at the indexing policy that you have defined. So very simple indexing policy. If you've used that before, you know that we include everything. So slash and the star. So we include everything, and just one field is excluded. So after running the schema analyzer, so you've seen that already. So Alpaca Studio is aware of, what fields do you have? How often are there in here? Other like where do we have it? Attributes. Look, there are some objects and some embedded entries and so on. So there's, potential of tens of hundreds. You never know. There could be an array suddenly that would be indexed. So there's a huge potential implication of indexing everything. And that's the suggested approach, to index everything, just to be on the safe side when you write your queries. But once you start looking after request units, your consumption. You start analyzing your data access patterns. Do you have the write heavy traffic or write heavy application? Then looking at that section really makes sense. So what we do here is we looked at every individual documents. We had the schema analyzer at work. We've seen how many fields you have per document, and we see your indexing policy. And now we tell you, hey, actually you're indexing up to 52 properties. Every single property is an expense. So let's switch to the advisor's view, and we tell you, well, it looks like you're at the maximum of potential write costs here. So we expect that when you write one of those largest documents, you land somewhere at 15 request units of writing a document, and that's the max. And with no indexing, of course, that's not something that you'd like to have, but you see that there's a lot of potential to improve. And again, that's something that's easily overlooked. And with Alpaca Studio, it's very easy to work with that. So let's just try to save a bit of your money and our money. So let's just exclude something. So I will just exclude attributes and everything that's in there, because I'm never searching afterwards. Let's assume that. I do this, and we should tell you, okay, if you apply that, you'll be indexing a lot of less properties, and so on. So we really help you with seeing what is the implication of having that index. It shouldn't discourage you of indexing everything, but it should make you aware of what could potentially happen, and it should give you a better understanding of, what are the implications of doing A or B. And now the advisor tells us, okay, the approximate cost will be around 10 request units. So it's 5 request units saved. You can do the math. If you do a lot of write operations, larger documents, you know what that means. But that's something in depth out pretty soon. We still have to cover composite and spatial indexes. That's why it's not there, because we didn't want to release something that's incomplete. But it's really, truly fun to use and really gives you a good understanding of what would happen if you deploy that indexing policy. All right, so that be that sneak peek into what's in depth. And I think there are just 2 slides I wanted to show you quickly. So reminder, managed, self-hosted, and desktop. Self-hosted available today, managed available immediately. So you just log in, you go to alpacastudio.com. There's a sign up button. There's a free edition that gives you a lot of those features that you've seen already. They're available to everyone. And desktop and command line interface are in depth. They're coming at a later stage. We're still collecting feedback on some of those, and the desktop edition for Windows will be the first one that we release. And where we are at today, roadmap wise. So you've seen a lot of those features around exploring and interacting with the data. Yeah, so this is something that we have today, and you can play with that already now. Tuning performance, that's something that's currently in development. So there's a lot of more features to come, but already the things we have are really powerful. So please give them a go, try it out, get in touch, give us your feedback, and tell us what your needs are. In Alpaca Studio, we advertise for a survey about performance tuning. There's also a link to that on our website. Please go there, share your performance tuning challenges with us, so that the first release of those new features potentially covers your needs already, in the first iteration. That'd be really great. Once we're done with the first iteration, import and export, more advanced, more features, exporting to Excel to CSV. It's partially there, but it'll be available for the full containers. Take a look at this. The same with importing data. This is something that we get a lot of requests. Hey, we have that file lying around. We just need to upload it, and we don't want to go through all the tooling. We just, we want to use Alpaca Studio, drag drop the file, and just have it there. It's in the pipeline, and once those features are available, then we'll look at automation and CLI, because we'd like to make sure that schema scanning should be available as a command line tool. So maybe you want to have it as a part of your build. Is the test data in the same shape that this was before? Do I have the same patterns? Do I have the same data types? Easily automated. And the same with copying data, importing, exporting, and so on. Well, thank you very much for your attention. I hope that was okay, despite of my voice today, and that you were able to follow. that my microphone wasn't muted. No, it wasn't. Great. Thanks a lot.
Wow, thanks a lot, Thomas. I think that was amazing. Like for data lovers and they're really passionate about seeing their data and all. I think it's really, really, really cool to see that. I really love the fact of, how we started off like those common data mistakes where you see like there's a different data type. I think that's something like, like data engineers or scientists get to encounter when they have like different data types, and you're trying to fix that. And for like, beginners who are not, new, you have like the tool that kind of like advances one from like a beginner to an expert. You can see how you can interact with the data. And then like, and the fact that, as you said, performance and RUs are something that everyone talks about when they're using their data. So seeing that you can, adjust your RUs or see how it affects your queries and be able to do some of those tunings and those index, and just seeing like the advisor, feature coming soon. I think it was like just awesome. And like, I don't know where to start from, but like, I think every piece, like from the data health, every piece was just like off the chat. Thanks a lot. Dilip, like, do you have questions?
I don't have a question, but I had a comment. It's really exciting to see such a beautiful visual tool for the data, right? It always makes you feel a little more closer to the data. I think the way we can see the schemas and create the queries and find out which fields to index or not to index, how to save money with respect to RUs, and sort of this. I think the next steps that you indicated, right, that is work in progress. Those are also like pretty exciting stuff, right? I think ability to performance tune and fine tune aspects of things, I think it will be greatly beneficial. Yeah, it's very exciting, Thomas. Thank you for giving us this session. It was really
Yeah, I really love that. And the fact that you can get like a tree view and a structure of your document. So I'm coming in new to the data, and I'm, I really can just like the whole graphical interface, actually just being able to like walk through. I think that's really good.
Thank you very much for your feedback. It's really enjoyable building the tool, and this really aligns with the feedback that we've been getting. So we started as a very interactive tool. That was the initial goal, to give software developers that direct raw access to the data. So of course it doesn't apply to every single scenario with Cosmos DB, because it has different aspects of how it can be used. But in those scenarios, when you really interact, you're right, to build an application, just use the database for some data storage easily, then having Alpaca Studio, just a data studio, is truly helpful. And that was the feedback that we've been getting. And once we got there, the next big challenge was precisely that, the performance tuning. That's something that we kind of knew from the start, because we had the same issues. But first, we needed a data studio to be there so that we can add those performance tuning features. There's more and more to come. And it's really heavily based on the user feedback, because there's no point in building a tool just for ourselves. Of course, it's fun. But truly, so it's really a big ask to everyone in the audience to just get in touch. If you like something, if you'd like to see something built in, or maybe even if there's something that you think that it wouldn't be useful, please let us know, because every single signal from the outside world is really powerful and helpful. So please tell us, every type of feedback. Even single line email helps. So don't be shy.
Sure.
Thank you.
Thank you. Thank you, Thomas. Thank you.
Thank you, Thomas. It was great.
Wow, Dilip, I think 3 hours went by like so fast. I can't believe like it went by like so fast, like with like sessions and speakers and just learning something new. I feel like I'm ready, like, to like, okay, start trying them out and, do some demo apps with my stuff that I do. So I think it's really cool.
Right. No, I think what you said is right. I can't deny the fact. These were like really good presentations, high energy, and lot of stuff to cover and learn and share, right? So it is I think this was really awesome. Just to think about it, right? The quick summary, like I think Reggie spoke about how to use change feed and all about change feed, how they implemented change feed on a fintech implementation, right, in a insurance product. He spoke about how resilient the system is for failures, how easy it is to scale up and scale down, the integration with Synapse, which was like really awesome. I spoke about the best practices, when to use, when not to use, and it was like really good. I think that was one thing, and I think you can share about Mihail, right?
Yeah. I think I really like that. I think I like what he said when he was like, "Oh, this is like the hidden gem of, you know, of Cosmos DB." I was like, "Okay,
Yeah.
that's cool." And then I think Mihail's presentation on serverless too was good, because I think it's something where when you're starting off building your application, you really don't want to, you kind of like figure out, am I doing like a critical workload or not a critical workload? Is the data, is it the data traffic, what is it like? Is it intermittent? And when should I use serverless to save cost? And I think that's one thing we did get from all the sessions, like how can I save cost and optimize and do like the idea. I think at the end of the goal is optimize throughput and RU. So yeah, it was that was it too, right?
Yeah, and following that session was Mark. I think we all in some way use chat applications. He spoke about a fully scalable chat app using Cosmos DB. The concept of real time and near real time, and what should be treated more important. I think that was like educational. Also the type of data, right? How it can be stored in Cosmos DB, and what type of data you can store it in Blob. I think that was also pretty useful, and like it was a guiding factor. And I know that he's trying to add more and more features onto the chat app and make it like more useful. And I think the GitHub links were all shared, and hopefully that people can go and contribute and give suggestions and make that a bigger success. So it's pretty exciting to see what type of real stuff can be done on Cosmos DB. So that was really awesome from Mark's session.
Yeah, I like that. I think that one of the things I mentioned that then was like, building chat apps. I didn't, you don't think about it. I think I probably thought about it in the hello world kind of sense, but with him showing like all of the different like domain objects and the architecture, I'm like, oh yes, it is. It's cool, and just having that open source out there for people that want to try it out and build on that. So really good. And then Jean talking about like investigating fraud on Cosmos DB. I'm thinking with like graph analytics. I think that started the whole graph presentation. And I know everyone's looking about with fraud these days, like how can we unmask fraud or money laundering rings, and how they're able to use that, being like the applications like graph analytics, how compatible it is with Azure Cosmos DB, and helping them, make faster investigations, catch anomalies and all of that. I just thought like, oh yeah, that's cool. Yes.
Yeah, the way he was able to bring in that second level or third level touch point, right, which was like sort of hidden, and how it can potentially be improved, how many common factors can be identified. I think, and especially in a visual fashion.
Yeah.
And all this in real quick time, always available for the person who is, let us say, trying to disperse a loan or trying to approve that particular funding. I think this real-time information at the right time, I think helps, in a big way. So
True.
I think,
That's
that
true.
was really awesome. And also Jake also gave us some good 101s on data modeling, if you're thinking from a graph perspective. Interesting tidbits on how to manage relationships and how to store data in Cosmos DB, right? So like all the businesses, how they consolidated the data. I think that was also useful. And of course, the introduction of Apache Airflow and how it can sort of customize the data based on the destination, and how you can transform it and make it more effective. I think that was also pretty useful.
Yeah, I think it's awesome with all the speakers and Thomas as we just rounded up with him, and just seeing how even Mihail mentioned about how, you know, they're introducing like Cosmos DB in the classes and all of that. Yeah, so we have some call to actions and stuff that you can do to keep up, Dilip.
Yeah, that's a good one. So yeah, I think see, there were like a lot of sessions, and this was the last one. We had the Americas, we had the APAC. So all these, there are 17 on-demand sessions for this conf, which will be made available, and I think the content will be really good for the community to consume. You can watch the sessions that you have missed or which was in a different time zone. You need to go to this URL, aka.ms/Azure Cosmos DB Conf. So that is the URL which can get you access to all the on-demand sessions.
Yes, and also join us for our podcast on Azure Cosmos DB Live TV. Our host, Mac Brown, he meets with our members from the Azure Cosmos DB team. So you can catch up on what's happening in the Cosmos DB community, or you can catch up on like new episodes or past episodes. Just go into the link, aka.ms/Cosmos DB Live TV.
Sure. And just in case if you are new to Cosmos DB, or you feel like trying Cosmos DB and you're used to some other database and you want to try it out, there are ways you can do it for free. So read our blog post on the 4 ways you can try Cosmos DB for free. The URL for that is aka.ms/Cosmos DB-free. So yeah, you can get your hands dirty. It's pretty easy. There is also an emulator, and there are a lot of options for you to try it out.
Yeah. So thank you for joining us for the Azure Cosmos DB conference today, and we hope that you all come back next year. Thank you. Bye-bye.
Thanks a lot. It was great. These were great sessions, and it was great to interact with all of you.
Thank you.